about that. This makes it extremely difficult to manage the risks that are created by existing underground utilities. This is a fact of life. The design engineer is not responsible for having the information of getting the information of the underground utilities, because it is supposed to come from the client. Client gets it from the old records. Contractor does the work as per the design, etc., etc. So ultimately, at the end of it, no one is answerable. So the problem is that there is no central repository for location of underground utilities. There is no single database from where you can get the location of underground utilities. No single agency monitoring the laying of new utilities. Non-availability of as-built drawings. We know very well that as-built drawings more often than not are replica of as-designed drawings. We will not go in detail why is the case there. And covering of manholes and inspection covers during laying of roads or relaying of roads basically eliminates practically all the signatures of utilities on the ground. So with this limited or almost no information, the design is carried out and even the construction starts. And then if we feel that we are a smart decision maker, well, we are a smart decision maker with our eyes closed. So why we need smart solutions? First, we don't know where most utilities are. Second, the existing records are often inaccurate or incomplete. Third, risks become extremely difficult to manage under such situation. And what are the risks? Project delays, damage to utilities, safety of workers, safety of public, redesign costs, change orders, bad publicity. All these are the risks which we are dealing with. So what is the answer? So now let's look at the answer. Before we look at the answer, I would like to understand, in your opinion, which is the most suitable or appropriate method or procedure to create maps of underground utilities? Ground penetrating radar, electronic pipe locators or induction locators, trenching or other? Of course, you will not be able to answer this question, but with my experience of doing this lecture live, the kind of answers I get, 42% say GPR, around 22% say EPL, and 27% say trenching, and around 9% say other. So that's the kind of response which we get. I will come back to this question at the end of this presentation again. So what actually is the answer? So the answer is new technologies for solutions, surface geophysics, surveying techniques, CAD and GIS, minimally intrusive excavation, all this. Convergence and systematic use of this data, and that is what we call SUE, Subsurface Utility Engineering. Now before I go forward on this, let me just tell you one thing. This entire concept of SUE started in US. Okay, that's right. So whatever we have talked about, the data not being available or data being inaccurate, etc., etc., this was felt in US in their transportation sector, and that's where they came up with the concept of SUE. So we are not talking about India. We are talking of a country which is supposed to have very good utility network, very well defined utility network. Despite that, they realize that if they are trusting only the data which is available, they are meeting with lots of problems, and that's how they came up with the concept of SUE. So what is SUE? What is subsurface utility engineering? So it is a proven process that incorporates new and existing technologies to accurately map underground utilities during the development of future construction projects. It encompasses several separate activities including designating, locating, surveying and mapping, all of which are performed under a professional program of data management. The essence of subsurface utility engineering is simple. Before an engineer designs a project involving excavation, the engineer should know what structures and conditions are beneath the earth and where they are in 3 dimensions. Such structures are usually utilities but may include underground storage tanks, septic fields and other things. That is basically what SUE is. It is use of new and existing technologies to accurately map underground infrastructure before you design a construction project or you execute a construction project. So it involves collection of underground utility data and the use of that data by the right parties at the right time. Its major components is designating, locating, surveying and mapping, and data management can be defined in terms of quality level of information. Now this quality level of information is the main thing which goes behind SUE. We will look in great detail. So quality level may be thought of as degrees of risk or how much information is really needed before planning, designing and constructing a project. So quality level, as the name indicates, it will tell you the quality of the information which is available. At the same time, what quality of information is required will depend on what stage of the project you are on. The importance of the concept of quality level will become very clear very soon. But if we look at the everyday life, we meet different kind of people. Now, it's not written on anyone's head, how reliable that person is. And that is the problem, right? If we knew, for example, that, this person is 100% reliable, this is 75% reliable, this is unreliable, we will never be cheated in life. Life will be so simple. But that is the concept, that what we are trying to do in SUE, that each information we are trying to give a particular label to the information so that we very clearly know what is the reliability of the information. So now let's go to this. This is the kind of maps we generally have available, the old maps. Now this is a simple ammonia blueprint. There are various roads here, and on these roads different color pens have been used to show different utilities. Now once you look at this particular map, there is no problem at all. You know that this particular color just shows that there is one particular line on this road somewhere. You will never try to try to take a judgment that this line is on the left or the right or the center of the road, because the tip of the sketch pen is as thick as the thickness of your road. No problems with this map. It is just a schematic to show that there are different pipelines on different parts of the road. So where the problem starts? Problem starts that when we are giving a map today, let's say we are given a beautiful printed CAD map. Do we have information on reliability level of these maps? Does the map mention anywhere that you can rely it 100% or 50% or 25%? Answer is no. Do we have information on data used for map preparation? How the map has been generated? The answer is no. Now the problem is that this kind of map, this kind of ammonia print which I had just shown you earlier, sometimes it is given for digitization. So it is given to, let's say, a CAD operator, and he starts digitizing this map. He puts these roads which are just 1 millimeter
on geophysical methods for pipeline rehabilitation projects.
In CAD, he will put these roads 20 meters
I am
apart.
Sanjay Rana. I am managing director of Parson.
He'll put
I am a professional.
Left, right, or center, depending on his judgment. Okay.
Please
so the information which was not there has been created during digitization,
and it's also used to detect
now this map will be given to you for your design purpose, and you will blow it up. You will try to see what is the distance of this pipeline from the road edge. Okay, it is 2 meters from the road edge. The information actually never existed. It has been just created in the process of digitization, and the map nowhere mentions that this map has been just created by digitization of a blueprint and should not be trusted for accurate location. No map ever gives you the reliability you can have on that. That's the problem. So SUE establishes nomenclature system to fix attribute to utility information to denote quality of utility information. That's the major thing in SUE. It basically develops establishes a nomenclature system which fix attributes to utility information to denote quality. What is the quality of the information? There are standards, of course, which deal with how information can be obtained, what technologies are available, how information can be conveyed to information users, etc. Intent is to reduce risk by improving the reliability of information on existing subsurface utilities in a defined manner. So now, once you are coming down, you know how much you can trust these people to actually hold you. There are certain definitions which are slightly different than what we generally understand. So it's important to designating is use of geophysics for presence and approximate position. Locating is exposing and recording precise vertical and horizontal location. There are so many practitioners who use the word locating for finding out underground utilities using GPR or induction locators. In terms of SUE, that is not locating, that is designating. Locating is only when we expose it. Then minimally intrusive excavation like
welcome to
vacuum
this
excavation,
guest
water
star
jet, careful
of
hand tool uses. Subsurface
So you
utility
can't-
engineer,
you
a person
cannot,
who by
as
education and
excavation
experience
should
is
be the best
qualified to
way
practice
forward.
SUE.
That trenchless
Utility
technology can
depiction
help
is
with
a
it.
visual image of
So thank you
existing
for listening.
information using a
There's
CAD
my
system or
contact
drafting
details,
system. And
and
most important, utility quality level. This is the opinion of quality and reliability of utility information. This you can say is the main aspect of the entire SUE process. That each and every utility must have an associated utility quality level. That all the information which is being provided to the user must know how much he can trust that information.
thing that was most likely to let down.
So there are different quality levels. Quality level D is information gathered solely from existing utility records. This is mostly what was being done till recently and is still being done in so many cases. So you just go to your old records, take out that information, and based on that make a utility composite and now use it for design. That is quality level D, the least reliable system, the least reliable quality level. Then comes quality level C, that now you had got a old drawing which was showing sewer lines somewhere on the road. Now you send your surveyors on the ground. They pick up the visible above ground utility facilities and appurtenances like manholes, like water walls, like junction boxes, etc. And now align the utilities known to be there through quality level D with the surface appurtenances. So this becomes quality level C data. This is definitely better in terms of reliability than quality level D, but still nowhere reliable enough to get into design or construction phase. Then comes quality level B. This is where it deviates the most from our traditional approach. This is where the major change is. It uses surface geophysical techniques to determine the existence and horizontal position of underground utilities. So here geophysical surveys come. Here, for example, GPR comes, induction locators come, electromagnetic surveys might come, magnetic surveys might come, etc., etc. There are a number of techniques which have been listed in terms of geophysical techniques which can be used for underground detection of utilities. Fact remains that there will be maximum 3 or 4 which can actually be used in urban environment. And last is quality level A, which employs non-destructive digging equipment at critical points to determine the precise horizontal and vertical position as well as size and type of underground utilities. That's very important to understand that even after this, it's not 100%. Quality level B does not give you everything. For example, GPR or any such technique does not give you size of the utility, the diameter of the utility, or the material of the utility, for example. Okay, so you have to go to quality level A if your project requires that kind of information requirement. There are standards like ASCE. This is one of the oldest standard by American Society of Civil Engineers. Then PAS 128. This is British, of course. Now the unique nature of utilities and record keeping in different countries necessitate various changes in the SUE approach. So in India, with INDSTT worked on this and came up with this code of practice for subsurface utility engineering suiting Indian condition, and it was brought out in 2018. So very briefly, I'll discuss about different quality levels. So as I said, quality level D is the most basic and the least desirable level of data. It comes solely from available utility owners' information. It has application for planning purposes such as selecting routes and estimating utility relocation cost. Now, very important note, this also has application. It's not useless, but for initial planning, pre-feasibility studies. Even though quality level D information may provide an overall feel for the congestion of utilities, it is highly limited in terms of comprehensiveness and accuracy for design purposes. So you cannot use it for design purposes. Can use it for pre-feasibility studies. So this is usually adequate for route selection, but make no mistake, this level of data is not adequate for design purposes. So it comes from record research, recollections, as-built drawings. This is the source of quality level D data. So this is, for example, Faridabad, the ULB map for master sewer plan. This will be a quality level D data. This again shows presence of pipelines, all these green lines. This will be the quality level D data. This is a map showing mid part of Hyderabad ULB's main supply line and overhead tanks. This is quality level D data. So this is the data which is very important to gather, of course, because this gives you a good start point for your further work, but this is not good for design purpose. Now, source of errors, of course, data is not referenced to change topographical features. For example, a pipe on side of the road comes in center when road is widened. Inaccuracy creeps in if utility layers are not referenced to MSL. So, for example, a pipe at depth of 1 meter will go to a depth of 1.2 meter with 20 centimeter road top added. As designed are mostly reproduced as built. So, quality level D, of course, as I said, is the least reliable source of data. Next comes quality level C. Historically, quality level C was probably the most commonly used level of information for design purposes. It involves supplementing quality level D information with an above ground survey of visible utility features such as manholes or wall boxes. Utility records and topside survey data are just not enough to provide an accurate picture of where subsurface utilities are located. Professional studies have shown a 30% error or omission rate with this approach. So, quality level C should rarely be used for design purposes when underground utilities are present. So, it's definitely an improvement on quality level D, but again, not good enough for design or construction. Here, this is mapping of surface utility features. You can use total station or DGPS, and that is what comes in quality level C. Then comes quality level B. So, quality level B is the first level where subsurface utility data departs from traditional practices. It involves supplementing quality level D information with designating, surveying, and mapping. Designating is the use of surface geophysical technologies to determine the existence of underground utilities in plan view. The use of this information allows decisions to be made during the preliminary design phase of the project in order to avoid conflicts with existing utilities. Slight adjustments in the design can produce substantial cost saving and increase safety by eliminating utility relocation and moving excavation work away from existing utilities. So this is where the major improvement comes in the entire process of detection and mapping of underground utilities. Now there are most commonly used tools. As I said, if you really go to the list, there will be more than 17 to 19 different methods which are listed. But fact is that in urban environment, the most commonly used tools are GPR, ground penetrating radar. This can detect both metallic and non-metallic utilities. It of course has capabilities and limitations. This session is too short to go in detail of it. Idea is just to give you an overview of SUV. There are few videos which are referred here. You are more than welcome to watch these videos. Second most commonly used tool is induction locator. GPR was working on the principle of electromagnetic reflection. Here we are working on the principle of electromagnetic induction. So again, this is very good for detection of metallic utilities, for detection of electrical cables, etc. It cannot detect non-metallic unless there is a tracer wire inside. Again, a different subject. But this is a separate second most commonly used tool. Then we have acoustic locators, which are used to detect very small water house connections, etc., which cannot be detected using GPR because of size issues. And we have separate gas pipeline locators. There are references here where you can go and look in details of all these techniques. So this is what comes under quality level B. And the next is quality level A. So quality level A information is the highest level of accuracy currently available. It involves adding locating to the quality level B information. Locating is the exposing of the buried utilities to determine their precise horizontal and vertical position in plan and profile view. So now we are not just working on the principle of, let's say, two-way travel time like we were doing in the quality level B, but actually we are exposing at particular position and inspecting the utilities. The use of non-destructive vacuum excavation equipment and other technologies eliminate damage to underground facilities. You cannot, for example, excavate using JCB or mechanized equipment. It has to be using non-destructive equipment. The small test hole reduces impact on traffic. Test hole is 20 centimeters by 20 centimeters, so it reduces pavement damages. So by knowing exactly where a utility is positioned in 3 dimensions, the designer can also make small adjustments to the final design elevation, horizontal location, or structure types to further avoid relocating utilities or digging near them. The engineer also gets critical data about utility condition, size, material types, soil conditions, and other important information, since you are actually digging and exposing the utilities. So this becomes, in a way, guarantee in 3D. So there are vacuum excavations, there are air vacuum excavation, there are water jet excavation, etc. We can also open the existing manholes and chambers. So this is one case. So this is, for example, power cable, then this is water pipeline, and this is the open chamber. So if you take the utility data using this also, it comes into quality level A. Again, you can have a video look at vacuum excavation, how it looks like. This is a very good video which is there. I have given a reference here. Ultimately, putting this all information together, we make subsurface utility maps. And well, depending on the project, we decide how these maps should be printed. But the fact is that any map becomes a subsurface utility map prepared using the process of subsurface utility engineering only and only if every utility has an associated quality level. If utilities are not having associated quality level, it is not an acceptable SUE map. So for example, this is a legend where different utilities have been shown, and here notes quality level A data point indicate by symbol this, elevations this, etc. So the point is that every utility should have an associated quality level, and then only it's a SUE map. Look at this map. This is from Mumbai. Yeah, this is from Mumbai, and you can see different utilities, and every utility will have an associated quality. This is the cable, quality level B, quality level B, quality level B. It means it has been detected using geophysics, etc. So this is the way a SUE map will always have an associated quality level. Now, SUE doesn't need to follow a set pattern. It is tailored for individual projects, so it's not a fixed pattern, but it involves systematically identifying the quality of utility information needed to design a project and acquiring and managing that level of information. So, for example, project planning, as I said, quality level D is sometimes good enough just for the initial project planning. Once you go to preliminary design, you can have completely go for quality level B data, no problem with that. But once you are going for final design and ultimately into construction, you have to have some test holes and related utility data. That means you must elevate your information to quality level A. So this is a proven solution. In many countries, it has been proven and given great results. These, of course, need for standardization. So first is procurement, of course. Be aware of false knowledge. It's more dangerous than ignorance. So how you engage a SUE provider is as important as whether you engage one at all, because an inaccurate subsurface utility engineering data is as dangerous and at times more than no data. So SUE service provider should be responsible for accuracy and reliability of the data delivered. Accountability is the key. Written quality assurance procedures, it's an interpretive science, so experience is critical. Equipment inventory is very important because no single equipment can provide all the information. So you need to have GPR, you need to have acoustic locators, you need to have induction locators, etc. There should be internal CAD capabilities and, of course, timely performance. So multidisciplinary approach. So the team should be a mix of geophysicists, surveyors, and CAD engineers, etc. This is basically the combination of SUE engineer, CAD engineer, utility engineer, geophysicist, survey engineer. So this is a stamp which I will talk about it later, but this actually is the person who can be called an SUE engineer. The Indian standards deal with what SUE engineer is. It deals with survey grades, level links to MSL, coordinate system, use of multiple technologies, clear identification of quality levels, experience, manpower, equipment, etc. Now, after going through again, I'll go to the same question. In your opinion, which is the most suitable, appropriate method or procedure to create accurate maps of underground utilities? And now, once I ask this question, around 96% people finally say it's subsurface utility engineering. So it is not GPR, it is not EPR, it is not trenching, it is SUE. GPR is nothing but a small part of SUE. So it's just one of the tools which should be used for detection of utilities and not 100% relied on. If you want to learn more about SUE, INDSTT is offering this SUE course with different modules, right from introduction to SUE to quality level D and C, B and A. This course is being jointly offered by INDSTT and AF Academy. And this is learning with certification. It's online through learning management system. So all the videos are there on the learning management system. The reading material is provided and you basically have to go through these videos. So this comprehensive course covering all the aspects of subsurface utility engineering like GPR, EPL, etc. with detailed description of data processing also. This is the only course which takes the learner through basics of SUE, data collection procedure for QLD and C, detailed procedure for QLB data collection using GPR, induction locator, acoustic locator, etc. QLA procedures including vacuum excavation, instruction of drawings preparation, etc. Upon successful participation, the participant would be awarded SUE engineer certificate with uniquely numbered stamp. This is the uniquely numbered stamp. Every stamp has a number to sign and certify underground utility drawings. There are less than 100 certified SUE engineers in India at present. The training program is approved by Engineering Council of India for the award of 224 continued professional development hours. With this, I come to the conclusion of this particular presentation on subsurface utility engineering. I would love to take your questions and thank you very much for your attention. Here is my email ID and my number. Please feel free to contact me for any queries. Thank you very much. Welcome to this presentation on geophysical methods for pipeline rehabilitation projects. I am Sanjay Rana. I am Managing Director of Parson. I am a professional geophysicist with 30 years of work experience. I graduated from University of Roorkee, which is now IIT Roorkee. I am a member of various working committees for development of codes and practices and standards, including IRC. I also frequently conduct training programs on use of geophysics for various applications. And I have the privilege of initiating the concept of SUE in India in 2001 and geophysical investigation across flowing rivers, dam geophysics, passive seismic tomography, etc. I represent the company Parson, which is an ISO certified company. We are the largest engineering geophysics company in the country, but more than that, we are known for the innovations we have been bringing in the country since 1996, when we introduced the concept of ground penetrating radar in India, the 97 shear wave seismic refraction, and the list goes on. And we are the leading and most experienced company in India in the field of near surface geophysics, including SUE. Our main strength is our people who are highly experienced and trained. We have offices in Delhi, Bhopal, Kolkata, and Bahrain, and in Saudi Arabia we are working with associates. And we have work experience of more than 14 countries around the world. Now, coming to geophysical investigations, I would just very briefly like to introduce the concept of geophysical investigations. So as we all are familiar with these images, they are basically medical images. We have, for example, ultrasound and X-ray and MRI and CT scan. And what we are doing here is sending different kind of rays and waves inside the body to capture the image of what's inside the body. That's what we are doing here. Now compare these images with the images here. These are the images created using geophysics. For example, this is a shear zone in an otherwise good bedrock created using electrical resistivity imaging. These are ray bars in a concrete slab created using ground penetrating radar. These are pipes buried under different layers of road created using GPR again. Here you see different layers of soil. This is a depth scale. So this has been created using seismic refraction tomography. Here you see boulders, zone of water accumulation, etc. This has been again created using ERI. So we are doing practically the similar kind of work which is being done in medical imaging. Here we are creating the images of the human body using different kind of rays and waves without actually cutting open the body or intruding inside the body. Same thing which we are doing with the earth, without cutting open, without drilling, without trenching to find out what's inside the earth. Our life is slightly more difficult than medical imaging profession for the simple reason that in human body we know what a normal human body looks like. For example, this always is taken as a joint, not as a fracture. But if there was something here, that would have been interpreted as a fracture. So there is something called a normal human body. Unfortunately, there is nothing called a normal earth. Earth changes from one point to the other. And that makes interpretation of geophysical data slightly more complex. Second is that human body is available for 360-degree inspection. You go inside this tunnel and all around you, you have transmitters and receiver. In case of geophysics, we only have the top surface available for the investigation. So that's the difference. But this is the best point to start understanding what geophysics is. So why to use it? The answer lies right in the comparison which I did earlier. It's always cheaper and faster to get an X-ray done than a surgery. So it's geophysics also low cost, rapid coverage, most importantly continuous information. The traditional way of doing drilling will always miss the isolated objects which are not directly in the drilling path. So drilling gives you only the discrete information, whereas geophysical methods give you continuous information. At the same time, I would like to highlight that geophysics does not replace drilling. It optimizes drilling. So rather than drilling randomly, once you do a good geophysical campaign, you have the continuous picture of the subsurface, and then you only need to drill at the anomaly locations to clearly understand what lies there. So this is the best part about combining and optimizing your drilling with geophysics. It leads to minimization of surprises, because whenever we meet a situation in the subsurface which we did not expect, we call it a geological surprise. Now geophysics helps you overcome that, and it's always good for early stage application for better planning and smooth execution. Now with this very small introduction to geophysics, I will right away go to the topic of the day, that's rehabilitation. So what all challenges we face in rehabilitation? One is the missing link. That is utility location. Sometimes a particular part or segment of utility is not exactly known where it is, and that's what we call missing link. Second is settled pipe. The pipe might have got settled because of defects at some location. Manhole location. As we are covering more and more manholes with the new road layers, sometimes we don't find manholes once we start working. And locating this manhole is a challenge. Then determination of leakage location for pipelines. Then detection of void and cavity along the pipeline. And lastly, pipeline condition assessment. So these are various challenges which are linked with rehabilitation, and I would like to take you through various methods which with few examples, since the total time is around 30 minutes. So I will be a little fast, but you are more than welcome to contact me on any further details. But I like to show you how it works. So first is utility location. Okay, finding out where a particular utility is. So exact location, orientation of utility, and information on missing link is required to be determined for proper planning of rehabilitation works. And for that, there are geophysical solutions, integrated approach of subsurface utility engineering, including tools like GPR, induction locators, acoustic locators, gas pipeline locators, magnetometers, EM surveying, etc. So there are a number of tools and a very well-defined set protocol of subsurface utility engineering which can be used to find out exact location and orientation of utilities for any of these projects. SUE is a subject in itself. There is a separate lecture on SUE which is available, and you can please go through that. Second, settled pipe. There are instances when a pipe settles due to defects or damages or loss of support. It is desirable to pinpoint such location and phenomena. And GPR is able to track the pipe and provide depth to the top of the pipe all along its length. Other supplementary tools can also be used based on site conditions. So for example, this is one very good example that this was a storm drain intake, and the GPR has been done all along the storm drain, and you can see how it is dipping from one end to the other. This is again the cross sections. You see the depth here. Depth here is greater and depth here is greatest. So like this, you are able to track the entire utility from one end to the other and see if there is a settlement of utility at one particular point. This is one very good example of this. This is a GPR profile from data collected along trend directly over top of a drainage pipe in saturated soil. Shows the abrupt transition from water filled pipe, that is west side. So this side is a water filled pipe, to an air filled pipe. This particular portion, east side. The abrupt transition in the GPR response is due to a pipe obstruction that completely blocks the flow of water. So this is a wonderful example of how a complete condition of a pipe has been tracked using GPR. Now the next objective is manhole location. So manholes routinely get buried during relaying of roads. It's of utmost importance to detect these manholes. So geophysical solution for that, manhole location can be determined using various tools, including but not limited to, it depends on the site condition, manhole locators, which you see here. This is one tool which again is working on the principle of almost like a metal detector, but more sophisticated. This is specifically made for manhole locations. GPR again comes in very handy for manhole location, metal detectors, magnetometers, EM surveying, etc. So there are different tools which are available for finding out the location of your manholes which are otherwise not visible, buried under the layer of road, etc. Condition assessment. Now we come to condition assessment. So when we talk about condition assessment, there are different condition assessment methods which we can talk about. We'll list them one by one. So first we are talking with leak detection. So once we talk of leak detection, there are different methods: acoustic, sonic, hydraulic. Okay. So there are various methods which are available for leak detection. Then electromagnetic methods for condition assessment, which include GPR, EM, cable detector, eddy currents. Then we have physical methods which include smoke testing, dye testing, impulse hammer. Then we have visual methods which include man entry and camera inspection. Then we have ultra or infraspectrum, which includes ultrasonic, infrared thermography. And in camera inspection also we have zoom camera, we have CCTV, we have SSCT. Now obviously I will not be able to go in detail of all these methods, but I'll try to show you a glimpse of various methods which are available. First, starting with leak detection. So there is a 3-step strategy for leakage management. First is localize to an area or zone, which is based on flow logging or noise logging. Second is locate, that is leak to within half a meter. Okay, so for which we use noise correlators. And then pinpoint, that is confirmation of the leak position, that for which we can use ground microphone. I'll be showing you all these steps. First is, let's say, localize. So once we do flow logging, let's say this is the minimum night flow, this red line which you see, and all the days of a minimum night flow remains the same. So basically it's an example of daily flow pattern with no serious problem. So this zone does not have any serious problem, and that's why minimum night flow remains at the minimum, has a trend which remains constant over all the days. Now let's go to a zone with serious problem. Okay. So here, for example, average daily flow was 1800 cubic meter per hour, and minimum night flow, this red line was the minimum night flow. we can see minimum light flow also is exceeding, and at the same time average daily flow also is exceeding. So this is a zone with serious problem. So that's how this flow logging helps you isolate the zones where leakage problem might be there. Now this is again district metering, continuous monitoring. One example, this is daily flow pattern, and this is a point of pipe burst, so the flow increases a lot. Again the zone is repaired, so zone returned normal after repair, and again we can see the normal flow coming here. So this is the flow logging concept. Then we have leak noise. So this is the basis of noise correlators, or listening to the leakage noise, which is the next step. Once you have isolated a zone of the leakage, now you are going to locate the leak, as they say. So depending on the backfill, the noise transfer is different. So depending on what is the soil type, your leak transfer to the surface will be different. The pressure within the pipe will affect the quantity of water being lost and the noise generated by the leak. So obviously, if you have high pressure inside the pipe, the leak noise will be higher. That's very easy to understand. And the size of leak will affect the transfer of noise. Again, big leaks will have a different noise, and small leaks will have a different noise. So let's look at this this phenomena. Let's say this is the burst. So energy generated from the leak is transmitted within the pipe through the water. So that's how energy will transfer within the water. Energy from the leak is also transmitted through the pipe wall. So this will also be carried through the pipe wall. Different material type of the pipe again will be giving different kind of signatures of your leakage. So if we talk about different material types which are used, there is steel, ductile iron, copper, asbestos, cement, lead, PVC, polyethylene, and this is the hardest and this is the softest material. Now, leak noise factors, the factors which produce good quality leak noise is high water pressure, hard backfill, small rupture, clean pipes, metallic pipes, and small diameter pipes. So if you have these conditions being met, you will have a very good quality leak noise. Whereas if you have low water pressure, soft backfill, split mains, and crusted pipes, soft lined pipes, and large diameter pipes, your leak noise will be of poor quality. So once we are talking about the noise correlators, or listening to the noise of the pipe, all these factors need to be considered. It's not that you will be able to listen to a good quality leak noise in all the cases. It depends on these factors. Okay. Now there are different levels, 40 dB to 100 dB leak found with noise loggers and usually with conventional methods. 10 dB to 40 dB leak found with noise loggers only, correlation generally required, and 0 dB to 10 dB no leaks. So leaks on plastic pipes are often found at the intensity of 20 to 40. So they can be found only with noise loggers and with correlation requirement. Once we talk about noise correlators, early correlators used to be very, very bulky. Okay, these days it has really changed. They are very small correlators. The basic principle is very simple. You have a transmitter here and you have a transmitter here. This is the leak. You measure the time of the propagation of the leak to both of these, and then you do the cross correlation, and that's why they call correlators, and you are able to pinpoint the location of noise. This is how it looks like. This is, for example, your different connections, and you are able to pinpoint where the leak is happening. Okay. So traditional style transmitters are positioned above the ground. So here you put it above the ground and you put your sensor here, take it inside the appendices and put it there. A wall chamber is left open. Now the cordless kind of transmitters are also there, which can actually be put inside below the ground, and you can actually close this chamber. Okay, so now once you do this, it becomes much more safer because your complete instrument is inside, your chamber is closed, and you can do the monitoring. Then there are ground mics and listening sticks. So this person is, for example, putting this headphone and using a ground mic for listening to the leak. Again, ground mic and listening devices here. So there, once you have located the leak, you can further localize it or pinpoint it using these devices. A leakage engineer locating a leak using a traditional listening stick, where it was directly put on air and the leak was listened to. Then again, this is a ground microphone. So this is a microphone put on the ground and you're listening to the sound which is coming to you from the leak. Now, there are optical fiber cable based measurements, but in this case you have to lay the optical fiber with the pipeline at the time of pipeline laying. It's a very effective system where you put the complete optical fiber. This fiber cable itself work as sensor. So fluid or gas leaks and sensing cables provide early detection. It's a very good method. It is used for oil and gas pipeline even today, where it is laid with the pipeline, and whenever there is a small leak starting, you get the signal. Okay, so the fiber itself is the sensor, and every meter you can say is a sensor which gives you the leakage position. Now, these are traditional methods like noise correlators, pretty popular, but there are certain cases because of pipe composition, because of low intensity of leakage and other factors which we listed. It's difficult to find the leak with noise correlators. Also, there are cases when, for example, you're not able to find any place to even put your transmitters of the noise correlators. So this is something we call finding the difficult leaks. And that's where GPR comes in picture. So GPR is a technique which is working on the principle of EM reflection. It is sending the electromagnetic impulses into the ground which get reflected from any interface across which there is change in dielectric constant. Now, whenever a leak is happening, it changes the dielectric properties of the soil around it. And that's the basic principle based on which GPR is being used successfully for leak detection. So this is one example which we did at the time of T3 construction. There were this fire hydrant line. These hydrant lines underground. This concrete was laid on top of them, and there were leakage from there. And we used GPR for leak detection there. And nowadays with 3D coming, this is called a heat map. So even heat maps can be created which very clearly tell you which is the zone which has been affected because of leakage. So this is one pipe, this is second pipe, and this is a heat map which has been generated, which very clearly tells you which segment of the pipe is responsible for this leakage. This is again a GPR image showing water accumulation from the leak. So this is water accumulation which has taken place because of leak. Another example, so GPR data before and after interpretation of image was this. So this was basically one pipe, and this is a truncated pipe here. This is a fractured main, and this is a leakage zone, and this is again a leakage zone. These two are the leakage zone from this fractured main. So this is the data which you receive. Of course, you have to interpret this data like this, and then you know the leakage zones. We did a lot of experimental work with the university on finding out these water leaks from water mains. This was in the city of Bangalore, and you can see we have collected different kind of signatures. So this is high amplitude reflections from saturated layer top. So all this work was done parallel to the water main. So we knew where the water main is. We first located the water main, and we did the work parallel to that. So this is, you can see this is the traces or distance. So we know at what particular point the leakage from the pipe has taken place because it is creating a saturated layer top there. Different kind of soils will have different kind of signatures. So again, this is a strong amplitude from water saturated layer top here. In this area, on the other hand, it is loss of signal due to increased conductivity caused by water saturation. So depending on kind of soil it is, you can have different signatures, and you need experience to interpret this, of course, but this is another signature of water leakage. Here, faded zone due to water saturation, it is called frequency filtering. Again, so we are going parallel to the pipeline, and we know exactly at what location the pipeline is leaking. This is an example of an area where the pipe was not holding any pressure. So first we did GPR data in affected area before water injection. Then we did the water injection. So GPR data in affected area after water injection. Note the deep feature between 11 meters to 16.5 meters disappears. So this is 10 meters. So this is a deep feature here. 11 meters to 16.5 meters. In this, it's not there. This is due to signal attenuation in the moist soil. So this basically proves that this is the area from where the leakage is taking place, because all other areas, both are exact replica of each other except this area where this reflection simply disappears. So that means the water injection has affected the conductivity of this particular area. There is another method to find difficult leaks, and that is based on acoustic. So we put geophones all along the pipeline. So these are geophones all along the pipeline. Like I had shown you earlier, this ground listening devices. So this is just a modern version of that. Instead of just having one device, you have 24 devices. So 24 geophones or 48 geophones you can put together. Rather than putting it in your ear, let the machine do the listening. So these are the geophones which have been put all along, and now wherever the leak is, you see the signature in the machine. So this is the distance, for example, at which the leak is taking place. And a very, very strong method. Now there are a few very interesting methods which have come up. One is smart ball technique. I'll just show a small video of this.
Smart ball technology is an innovative acoustic leak detection tool for pipelines, 4 inches in diameter and larger. The tool consists of an instrumented aluminum core housed within a urethane or foam shell. The Smart Ball inspection tool can be easily deployed and retrieved using existing pigging facilities. In non-piggable lines, the tool can be launched using standard off-the-shelf fittings. Once inside the pipeline, Smart Ball easily rolls along the bottom of the pipe as it is propelled by the product flow. Since Smart Ball isn't a full-bore tool, it can easily navigate any bends within the line. Smart Ball can be tracked using surface mount sensors, typically placed on block or check valves, as well as using above-ground markers placed at selected surveyed points. As the Smart Ball navigates the line, it continuously records acoustic data. As it approaches a leak, a very distinct noise signature can be heard. Smart Ball has been able to detect leaks as low as 0.03 gallons per minute. Once the Smart Ball has completed the inspection, it is easily removed from the line. Smart Ball is ideal for long inspection runs, as the onboard battery can last several hundred hours.
So very, very interesting tools are coming up, and Smart Ball actually is not very new. It is being used. If you need more details about it, please write to me. I'll love to share. Now I'll very briefly talk about other condition assessment tools. So one is smoke testing, right? So in this, we force a smoke-filled air through a sewer line. The pressurized smoke will fill the main line and any other connections, then follow the path of the leak to the ground surface. So this is one way to find out leakages in sewer lines, smoke testing. Then there is dye testing. So dye testing with a non-toxic dye is used to confirm rain or ground entry points into the sanitary sewer system. Dyed water is introduced, roof drain leaders, driveway drains or area drains. In some instances, dyed water is injected into the ground around foundations to check for the illegal connections of foundation drains. After introducing the dyed water, the downstream sanitary sewer manhole is checked, and if a clean out is present, it is checked for presence of dyed water. Dye testing is one way of helping to determine whether a pipe or a structure drained if it is not obvious by observation or shown on existing plan records. Dye testing can help identify inappropriate connections also. Then we have CCTV. Most of you will be familiar with this. So this technology uses a television camera mounted on a remotely controlled self-propelled robotic device that is connected to a video monitor, a video cassette recorder and other recording devices by a long electric cable to inspect sewer lines. The robotic system is placed directly into the sewer through a manhole. Once inside the sewer line, the remote controlled device moves through the sewers and allows the operator to examine the entire length of pipeline between two manholes. The CCTV system relays live footage to a high-resolution monitor located in a mobile survey unit. The footage of pipeline surveyed is recorded on videotape. If a defect is detected, the operator can stop the camera and investigate the defect in more details. In fact, lately there have been a lot of development on CCTV technology, and so many different kind of systems are available now. Then we have radiometric probes, which uses neutron and gamma ray backscatter probes for detection of cracks. Passing a joint or a cavity behind the pipe with the probe, the counting rate of the backscattered counts changes in a typical way. So this is another technique which is used for pipeline condition assessment. We have current probes, which are geoelectric sensors, measures variations in ground resistivity, and it's also used to detect the leak points. Again, we have electromagnetics, which measures wall thickness of a pipe by sensing the attenuation and phase delay of EM signal which is passed through the pipe wall. With this, I come to conclusion of this session. I have tried to cover up practically a lot of things in a very short time, but I'm always available to answer your questions, and these are my contact details. Please feel free to write to me if you want to understand more on any of these aspects which we have discussed in this presentation. I wholeheartedly thank you for your attention.
सेंटर में फूड प्रिजर्वेशन का ट्रेनिंग ले रही हूँ। यहाँ पे हम प्रैक्टिकल कर रही हूँ। यहाँ पे हमें अचार बनाना, जाम बनाना, जेली बनाना आदि सिखाया गया है, और उसके साथ यहाँ पे मार्केटिंग और पैकेजिंग की भी सिखाया गया है। हम जॉब कर सकते हैं या जॉब नहीं भी करें तो उसके द्वारा हम अपना बिजनेस शुरू कर सकते हैं। इसीलिए मैं CIDC और AAI को धन्यवाद देना चाहती हूँ। वो हमें ये सिखाया कि हमें अपने पैरों पर खुद खड़ा होना सिखाया। इसलिए थैंक यू।
मैं CIDC में ट्रेनिंग करने के लिए आया हूँ, जो कि मिनिस्टर ब्रह्मो इंजीनियरिंग कॉलेज में कराया जा रहा है, जो कि कोकराझार डिस्ट्रिक्ट में है, असम में। मैं जो ट्रेड लिया हुआ हूँ वो है जनरल वर्क सुपरवाइजर का।
ऑटो लेवल एक डिवाइस होता है जिसके जरिए लेवल जमीन का और दूसरी चीज़ों का लेवलिंग लिया जाता है। इस डिवाइस के मुख्य पार्ट्स हैं ये ट्राइपॉड स्टैंड में ये ट्राइपॉड स्क्रू होता है जिसके ज़रिए इसका हाइट एडजस्ट किया जाता है और हाइट के साथ साथ इसका लेवल भी एडजस्ट किया जाता है।
I belongs from Risu, Meghalaya. I first 10 class. My father is a farmer. He earns just rupees 300 daily for family. There is not sufficient. I heard about my son training. Started at Risu Velpara by CIDC. I got admission and learning a lot about house construction. I learned about foundation, cement, sand, etc. By taking this training, I can make my future is better way. Thanks a lot to CIDC.
आफ्टर 10 पास में बेरोजगार था तो मेरा दोस्त राज ने बताया CIDC के बारे में, और मैं CIDC सेंटर गोलाघाट ट्रेड प्लम्बर में ज्वाइन किया।
हम लोग गांव में कोई भी काम नहीं मिला, इसलिए हम लोग जो सेंटर से हम लोग को बोला, इसलिए वो लोग दिल्ली से सब लोग आया और CIDC वेलफेयर में अच्छा काम करना मिलेगा बोला, इसलिए हम लोग ट्रेनिंग के लिए CIDC के आया। और हम लोग ये CIDC ट्रेनिंग खत्म होने के बाद हम अच्छा काम चुनेगा।
यहाँ मैं सिगोली CIDC सेंटर में फूड प्रिजर्वेशन में ट्रेड पे हम लोगों को आम के अचार, जाम, स्क्वायर बनाना सिखा रही है। तो यहाँ पे हम लोग यह बेल की स्क्वायर बना रही हूँ। तो ये सीखने के बाद हम लोग पैकेजिंग और मार्केटिंग भी सीखेंगे और सीख भी रही हूँ। और ये इसके लिए हमें तो फ्री में CIDC और AAI हमें तो फ्री में ट्रेनिंग दे रही है। इसके लिए हम CIDC को और AAI को थैंक यू बोलना चाहती हूँ, जो हम लोगों को फ्री में ट्रेनिंग दे रहे हैं। और मैं खुद ये सीखने के बाद मैं खुद के बिजनेस शुरू करूँगी, अगर मुझसे हो सके तो मैं जॉब भी करना चाहूँगी।
My father is a teacher. I'm taking training in Muslim Trade at Nongstoin Center. I have learned about the construction material measurement, the foundation, brick, masonry, extra from Pawan, from South Pawan. After training, I can work this trade and earn my living.
हम लोग अभी पहले तो हम लोग 200 रुपया ऐसा मांगेगा। अभी हम लोग CIDC ट्रेनिंग लेने के बाद हम लोग जो काम उसको हम लोग सीखेगा, उसको हम लोग अभी 500, 600, 700 ऐसा मांगेगा।
मैं असम से आई हूँ, मेरा डिस्ट्रिक्ट गोलाघाट। मैं पहले से गोलाघाट इंजीनियरिंग कॉलेज में CIDC पार्ट की सब्जेक्ट फूड प्रिजर्वेशन के लिए 3 मंथ की कोचिंग करने के लिए आई थी। वहाँ मैंने फूड प्रिजर्वेशन क्या है वो सीखा है। तो वहाँ पर मैंने सिडोली सेंटर में ट्रांसफ़र की गई है। यहाँ पहला दिन से मैं आचार, जैम, जेली कैसे बनाती है वो सब सीखा है। और उसके बाद मैंने मार्केटिंग और पैकेजिंग भी बहुत सारी बातें सीखने के मिले हैं। तो इसीलिए मैं जो भी जॉब और ना तो मैं अपनी बिजनेस शुरू करना चाहती हूँ। सेंटर में फूड प्रिजर्वेशन का ट्रेनिंग ले रही हूँ। यहाँ पे हम प्रैक्टिकल कर रही हूँ। यहाँ पे हमें आचार बनाना, जाम बनाना, जेली बनाना आदि सिखाया गया है। और उसके साथ यहाँ पे मार्केटिंग और पैकेजिंग की भी सिखाया गया है। हम जॉब कर सकते हैं या जॉब नहीं भी करें तो उसके द्वारा हम अपना बिजनेस शुरू कर सकते हैं। इसीलिए मैं CIDC और AAI को धन्यवाद देना चाहती हूँ। वो हमें ये सिखाया कि हमें अपने पैरों पर खुद खड़ा होना सिखाया। इसलिए थैंक यू।
मैं CIDC में ट्रेनिंग करने के लिए आया हूँ, जो कि मिनेश्वर ब्रह्मो इंजीनियरिंग कॉलेज में कराया जा रहा है, जो कि कोरल डिस्ट्रिक्ट में है, असम में। मैं जो ट्रेड लिया हुआ हूँ वो है जनरल वर्क सुपरवाइजर का।
ऑटो लेवल एक डिवाइस होता है जिसके जरिए ज़मीन का और दूसरी चीज़ों का लेवलिंग लिया जाता है। इस डिवाइस के मुख्य पार्ट्स हैं ये ट्राइपॉड स्टैंड में ये ट्राइपॉड स्क्रू होता है जिसके ज़रिए इसका हाइट एडजस्ट किया जाता है और हाइट के साथ साथ इसका लेवल भी एडजस्ट किया जाता है।
I belongs from Risu, Meghalaya. I first 10 class. My father is a farmer. He earns just rupees 300 daily for family. That is not sufficient. I heard about my son training. Started at Risu Welfare by CIDC. I got admission and learning a lot about house construction. I learned about foundation, cement, sand, etc. By taking this training, I can make my future is better way. Thanks a lot to CIDC.
आफ्टर 10 पास में बेरोजगार था तो मेरा दोस्त राज ने बताया CIDC के बारे में। और मैं CIDC सेंटर गोलाघाट ट्रेड प्लम्बर में ज्वाइन किया।
हम लोग गांव में कोई भी काम नहीं मिला, इसलिए हम लोग जो सेंटर से हम लोग को बोला, इसलिए वो लोग दिल्ली से सब लोग आया और ऋषि वेलफेयर में अच्छा काम करना मिलेगा बोला, इसलिए हम लोग ट्रेनिंग के लिए CIDC के आया। और हम लोग ये CIDC ट्रेनिंग खत्म होने के बाद हम अच्छा काम चुनेगा।
यहाँ मैं सिगोली CIDC सेंटर में फूड प्रिजर्वेशन में ट्रेड पे हम लोगों को आम के आचार, जाम, स्क्वायर बनाना सिखा रहे हैं। तो यहाँ पे हम लोग ये बेल की स्क्वायर बना रही हूँ। तो ये सीखने के बाद हम लोग पैकेजिंग और मार्केटिंग भी सीखेंगे और सीख भी रही हूँ। और ये इसके लिए हमें तो फ्री में CIDC और AAI हमें तो फ्री में ट्रेनिंग दे रही है। इसके लिए हम CIDC को और AAI को थैंक यू बोलना चाहते हूँ, जो हम लोगों को फ्री में ट्रेनिंग दे रहे हैं। और मैं खुद ये सीखने के बाद मैं खुद के बिजनेस शुरू करूँगी। अगर मुझसे हो सके तो मैं जॉब भी करना चाहूँगी।
My father is a teacher. I'm taking training in Muslim trade at Nongstoin Center. I have learned about the construction material, measurement, the foundation, brick, masonry, extra from South Pawan. After training, I can work this trade and earn my living.
हम लोग अभी पहले तो हम लोग 200 रुपया ऐसा मांगेगा। अभी हम लोग CIDC से ट्रेनिंग लेने के बाद हम लोग जो काम उसको हम लोग सीखेगा, उसको हम लोग अभी 500, 600, 700 ऐसा मांगेगा।
मैं असम से आई हूँ, मेरा डिस्ट्रिक्ट गोलाघाट। मैं पहले से गोलाघाट इंजीनियरिंग कॉलेज में CIDC पार्ट की सब्जेक्ट फूड प्रिजर्वेशन के लिए 3 मंथ की कोचिंग करने के लिए आई थी। वहाँ मैंने फूड प्रिजर्वेशन क्या है वो सीखा है। तो वहाँ पर मैंने सिडोली सेंटर में ट्रांसफ़र की गई है। यहाँ पहला दिन से मैं आचार, जैम, जेली कैसे बनाती है वो सब सीखा है। और उसके बाद मैंने मार्केटिंग और पैकेजिंग भी बहुत सारी बातें सीखने के मिले हैं। तो इसीलिए मैं जो भी जॉब और ना तो मैं अपनी बिजनेस शुरू करना चाहती हूँ। सेंटर में फूड प्रिजर्वेशन का ट्रेनिंग ले रही हूँ। यहाँ पे हम प्रैक्टिकल कर रही हूँ। यहाँ पे हमें अचार बनाना, जाम बनाना, जेली बनाना आदि सिखाया गया है और उसके साथ यहाँ पे मार्केटिंग और पैकेजिंग की भी सिखाया गया है। हम जॉब कर सकते हैं या जॉब नहीं भी करें तो उसके द्वारा हम अपना बिजनेस शुरू कर सकते हैं। इसीलिए मैं CIDC और AI को धन्यवाद देना चाहती हूँ। वो हमें ये सिखाया कि हमें अपने पैरों पर खुद खड़ा होना सिखाया। इसलिए थैंक यू।
मैं CIDC में ट्रेनिंग करने के लिए आया हूँ, जो कि बिनेश्वर ब्रह्मो इंजीनियरिंग कॉलेज में कराया जा रहा है, जो कि कोरल डिस्ट्रिक्ट में है, असम में। मैं जो ट्रेड लिया हुआ हूँ वो है जनरल वर्क सुपरवाइजर का।
ऑटो लेवल एक डिवाइस होता है जिसके जरिए ज़मीन का और दूसरी चीज़ों का लेवलिंग लिया जाता है। इस डिवाइस के मुख्य पार्ट्स हैं ये ट्राइपॉड स्टैंड में ये ट्राइपॉड स्क्रू होता है जिसके ज़रिए इसका हाइट एडजस्ट किया जाता है और हाइट के साथ साथ इसका लेवल भी एडजस्ट किया जाता है।
I belongs from Risu, Meghalaya. I first 10 class. My father is a farmer. He earns just rupees 300 daily for family. That is not sufficient. I heard about my son training. Started at Risu Belpara by CIDC. I got admission and learning a lot about house construction. I learned about foundation, cement, sand, etc. By taking this training, I can make my future is better way. Thanks a lot to CIDC.
आफ्टर 10 पास में बेरोजगार था तो मेरा दोस्त राज ने बताया CIDC के बारे में और मैं CIDC सेंटर गोलाघाट ट्रेड प्लम्बर में ज्वाइन किया।
हम लोग गांव में कोई भी काम नहीं मिला, इसलिए हम लोग जो सेंटर से हम लोग को बोला, इसलिए वो लोग दिल्ली से सब लोग आया और ऋषि बेलपारा में अच्छा काम करना मिलेगा बोला, इसलिए हम लोग ट्रेनिंग के लिए CIDC के आया और हम लोग ये CIDC ट्रेनिंग खत्म होने के बाद हम अच्छा काम चुनेगा।
यहाँ मैं सिद्धौली CIDC सेंटर में फूड प्रिजर्वेशन में ट्रेड पे हम लोगों को आम के अचार, जाम, स्क्वायर बनाना सिखा रही है। तो यहाँ पे हम लोग ये बेल की स्क्वायर बना रही हूँ। तो ये सीखने के बाद हम लोग पैकेजिंग और मार्केटिंग भी सीखेंगे और सीख भी रही हूँ। और ये इसके लिए हमें तो फ्री में CIDC और AI हमें तो फ्री में ट्रेनिंग दे रही है। इसके लिए हम CIDC को और AI को थैंक यू बोलना चाहती हूँ, जो हम लोगों को फ्री में ट्रेनिंग दे रहे हैं। और मैं खुद ये सीखने के बाद मैं खुद के बिजनेस शुरू करूँगी। अगर मुझसे हो सके तो मैं जॉब भी करना चाहूँगी।
My father is a teacher. I'm taking training in Muslim Trade at Nongstoin Center. I have learned about the construction material, measurement, the foundation, brick, masonry, extra from Pawan, from Sir Pawan. After training, I can work this trade and earn my living.
हम लोग अभी पहले तो हम लोग 200 रुपया ऐसा मांगेगा। अभी हम लोग CIDC ट्रेनिंग लेने के बाद हम लोग जो काम उसको हम लोग सीखेगा, उसको हम लोग अभी 500, 600, 700 ऐसा मांगेगा।
मैं असम से आई हूँ, मेरा डिस्ट्रिक्ट गोलाघाट। मैं पहले से गोलाघाट इंजीनियरिंग कॉलेज में CIDC पार्ट की सब्जेक्ट फूड प्रिजर्वेशन के लिए 3 मंथ की कोचिंग करने के लिए आई थी। वहाँ मैंने फूड प्रिजर्वेशन किया है, वो सीखा है। तो वहाँ का मैंने सिद्धौली सेंटर में ट्रांसफ़र की गई है। यहाँ पहला दिन से मैं अचार, जैम, जेली कैसे बनाती है वो सब सीखा है। और उसके बाद मैंने मार्केटिंग और पैकेजिंग भी बहुत सारी बातें सीखने के मिले हैं। तो इसीलिए मैं जो भी जॉब और ना तो मैं अपनी बिजनेस शुरू करना चाहती हूँ। सेंटर में फूड प्रिजर्वेशन का ट्रेनिंग ले रही हूँ। यहाँ पे हम प्रैक्टिकल कर रही हूँ। यहाँ पे हमें अचार बनाना, जाम बनाना, जेली बनाना आदि सिखाया गया है और उसके साथ यहाँ पे मार्केटिंग और पैकेजिंग की भी सिखाया गया है। हम जॉब कर सकते हैं या जॉब नहीं भी करें तो उसके द्वारा हम अपना बिजनेस शुरू कर सकते हैं। इसीलिए मैं CIDC और AI को धन्यवाद देना चाहती हूँ। वो हमें ये सिखाया कि हमें अपने पैरों पे खुद खड़ा होना सिखाया, इसलिए थैंक यू।
मैं CIDC में ट्रेनिंग करने के लिए आया हूँ, जो कि मिनेश्वर ब्रह्मो इंजीनियरिंग कॉलेज में कराया जा रहा है, जो कि कोरल डिस्ट्रिक्ट में है, असम में। मैं जो ट्रेड लिया हुआ हूँ वो है जनरल वर्क सुपरवाइजर का।
ऑटो लेवल एक डिवाइस होता है जिसके जरिए ज़मीन का और दूसरी चीज़ों का लेवलिंग लिया जाता है। इस डिवाइस के मुख्य पार्ट्स हैं ये ट्राइपॉड स्टैंड में ये ट्राइपॉड स्क्रू होता है जिसके ज़रिए इसका हाइट एडजस्ट किया जाता है और हाइट के साथ साथ इसका लेवल भी एडजस्ट किया जाता है।
I belongs from Risu, Meghalaya. I first 10 class. My father is a farmer. He earns just rupees 300 daily for family. There is not sufficient. I heard about my son training. Started at Risu Welfare by CIDC. I got admission and learning a lot about house construction. I learned about foundation, cement, sand, etc. By taking this training, I can make my future is better way. Thanks a lot to CIDC.
आफ्टर 10 पास में बेरोजगार था, तो मेरा दोस्त राज ने बताया CIDC के बारे में, और मैं CIDC सेंटर गुलाघाट ट्रेड प्लम्बर में ज्वाइन किया।
हम लोग गांव में कोई भी काम नहीं मिला, इसलिए हम लोग जो सेंटर से हम लोग को बोला, इसलिए वो लोग दिल्ली से सब लोग आया और ऋषि वेलफेयर में अच्छा काम करना मिलेगा बोला, इसलिए हम लोग ट्रेनिंग के लिए CIDC के आया। और हम लोग ये CIDC ट्रेनिंग खत्म होने के बाद हम अच्छा काम चुनेगा।
यहाँ मैं सिगोली CIDC सेंटर में फूड प्रिजर्वेशन में ट्रेड पे हम लोगों को आम के आसार, जाम, स्क्वायर बनाना सिखा रहे हैं। तो यहाँ पे हम लोग ये बेल की स्क्वायर बना रही हूँ। तो ये सीखने के बाद हम लोग पैकेजिंग और मार्केटिंग भी सीखेंगे और सीख भी रही हूँ। और ये इसके लिए हमें तो फ्री में CIDC और AI हमें तो फ्री में ट्रेनिंग दे रही है। इसके लिए हम CIDC को और AAI को थैंक यू बोलना चाहती हूँ, जो हम लोग को फ्री में ट्रेनिंग दे रहे हैं। और मैं खुद ये सीखने के बाद मैं खुद के बिजनेस शुरू करूँगी, अगर मुझसे हो सके तो मैं जॉब भी करना चाहूँगी।
My father is a teacher. I'm taking training in Muslim Trade at Nongstoin Center. I have learned about the construction material, measurement, the foundation, brick, masonry, extra from Pawan, from Sir Pawan. After training, I can work this trade and earn my living.
हम लोग अभी पहले तो हम लोग 200 रुपया ऐसा मांगेगा। अभी हम लोग CIDC ट्रेनिंग लेने के बाद हम लोग जो काम उसको हम लोग सीखेगा, उसको हम लोग अभी 500, 600, 700 ऐसा मांगेगा।
मैं असम से आई हूँ, मेरा डिस्ट्रिक्ट गोलाघाट। मैं पहले से गोलाघाट इंजीनियरिंग कॉलेज में CIDC पार्ट की सब्जेक्ट फूड प्रिजर्वेशन के लिए 3 मंथ की कोचिंग करने के लिए आई थी। वहाँ मैंने फूड प्रिजर्वेशन क्या है वो सीखा है। तो वहाँ पर मैंने सिडोली सेंटर में ट्रांसफ़र की गई है। यहाँ पहला दिन से मैं आसार, जैम्स, जेली कैसे बनाती है वो सब सीखा है। और उसके बाद मैंने मार्केटिंग और पैकेजिंग भी बहुत सारी बातें सीखने के मिले हैं। तो इसीलिए मैं जो भी जॉब और ना तो मैं अपनी बिजनेस शुरू करना चाहती हूँ। सेंटर में फूड प्रिजर्वेशन का ट्रेनिंग ले रही हूँ। यहाँ पे हम प्रैक्टिकल कर रही हूँ। यहाँ पे हमें अचार बनाना, जाम बनाना, जेली बनाना आदि सिखाया गया है। और उसके साथ यहाँ पे मार्केटिंग और पैकेजिंग की भी सिखाया गया है। हम जॉब कर सकते हैं या जॉब नहीं भी करें तो उसके द्वारा हम अपना बिजनेस शुरू कर सकते हैं। इसीलिए मैं CIDC और AAI को धन्यवाद देना चाहती हूँ। वो हमें ये सिखाया कि हमें अपने पैरों पे खुद खड़ा होना सिखाया, इसलिए थैंक यू।
मैं CIDC में ट्रेनिंग करने के लिए आया हूँ, जो कि मिनेश्वर ब्रह्मो इंजीनियरिंग कॉलेज में कराया जा रहा है, जो कि कोरल डिस्ट्रिक्ट में है, असम में। मैं जो ट्रेड लिया हुआ हूँ वो है जनरल वर्क सुपरवाइजर का।
ऑटो लेवल एक डिवाइस होता है जिसके जरिए ज़मीन का और दूसरी चीज़ों का लेवलिंग लिया जाता है। इस डिवाइस के मुख्य पार्ट्स हैं ये ट्राइपॉड स्टैंड में ये ट्राइपॉड स्क्रू होता है जिसके ज़रिए इसका हाइट एडजस्ट किया जाता है और हाइट के साथ साथ इसका लेवल भी एडजस्ट किया जाता है।
I belongs from Risu, Meghalaya. I first 10 class. My father is a farmer. He earns just rupees 300 daily for family. There is not sufficient. I heard about my son training. Started at Risu Welfare by CIDC. I got admission and learning a lot about house construction. I learned about foundation, cement, sand, etc. By taking this training, I can make my future is better way. Thanks a lot to CIDC.
आफ्टर 10 पास में बेरोजगार था तो मेरा दोस्त राज ने बताया CIDC के बारे में और मैं CIDC सेंटर गोलाघाट ट्रेड प्लम्बर में ज्वाइन किया।
हम लोग गांव में कोई भी काम नहीं मिला इसलिए हम लोग जो सेंटर से हम लोग को बोला इसलिए वो लोग दिल्ली से सब लोग आया और ऋषि वेलफेयर में अच्छा काम करना मिलेगा बोला इसलिए हम लोग ट्रेनिंग के लिए CIDC के आया और हम लोग ये CIDC ट्रेनिंग खत्म होने के बाद हम अच्छा काम चुनेगा।
यहाँ मैं सिद्धोली CIDC सेंटर में फुटवी सर्विस में ट्रेड पे हम लोगों को आम के आसार, जाम, स्क्वायर बनाना सिखा रहे हैं। तो यहाँ पे हम लोग ये बेल की स्क्वायर बना रही हूँ। तो ये सीखने के बाद हम लोग पैकेजिंग और मार्केटिंग भी सीखेंगे और सीख भी रही हूँ। और ये इसके लिए हमें तो फ्री में CIDC और AI हमें तो फ्री में ट्रेनिंग दे रही है। इसके लिए हम CIDC को और AI को थैंक यू बोलना चाहते हूँ जो हम लोगों को फ्री में ट्रेनिंग दे रहे हैं। और मैं खुद ये सीखने के बाद मैं खुद के बिजनेस शुरू करूँगी। अगर मुझसे हो सके तो मैं जॉब भी करना चाहूँगी।
My father is a teacher. I'm taking training in Muslim trade at Nongstoin Center. I have learned about the construction material, measurement, the foundation, brick, masonry, extra from Pawan, from South Pawan. After training, I can work this trade and earn my living.
हम लोग अभी पहले तो हम लोग 200 रुपया ऐसा मांगेगा। अभी हम लोग CIDC ट्रेनिंग लेने के बाद हम लोग जो काम उसको हम लोग सीखेगा उसको हम लोग अभी 500, 600, 700 ऐसा मांगेगा।
मैं असम से आई हूँ, मेरा डिस्ट्रिक्ट गोलाघाट। मैं पहले से गोलाघाट इंजीनियरिंग कॉलेज में CIDC पार्ट की सब्जेक्ट फूड प्रिजर्वेशन के लिए 3 मंथ की कोचिंग करने के लिए आई थी। वहाँ मैंने फूड प्रिजर्वेशन क्या है वो सीखा है। तो वहाँ पर मैंने सिद्धोली सेंटर में ट्रांसफ़र की गई है। यहाँ पहला दिन से मैं आचार, जैम, जेली कैसे बनाती है वो सब सीखा है। और उसके बाद मैंने मार्केटिंग और पैकेजिंग भी बहुत सारी बातें सीखने के मिले हैं। तो इसीलिए मैं जो भी जॉब और ना तो मैं अपनी बिजनेस शुरू करना चाहती हूँ। सेंटर में फूड प्रिजर्वेशन का ट्रेनिंग ले रही हूँ। यहाँ पे हम प्रैक्टिकल कर रही हूँ। यहाँ पे हमें अचार बनाना, जाम बनाना, जेली बनाना आदि सिखाया गया है। और उसके साथ यहाँ पे मार्केटिंग और पैकेजिंग की भी सिखाया गया है। हम जॉब कर सकते हैं या जॉब नहीं भी करें तो उसके द्वारा हम अपना बिजनेस शुरू कर सकते हैं। इसीलिए मैं CIDC और AI को धन्यवाद देना चाहती हूँ। वो हमें ये सिखाया कि हमें अपने पैरों पर खुद खड़ा होना सिखाया। इसलिए थैंक यू।
मैं CIDC में ट्रेनिंग करने के लिए आया हूँ जो कि मिनेश्वर ब्रह्मो इंजीनियरिंग कॉलेज में कराया जा रहा है जो कि कोराझर डिस्ट्रिक्ट में है, असम में। मैं जो ट्रेड लिया हुआ हूँ वो है जनरल वर्क सुपरवाइजर का।
ऑटो लेवल एक डिवाइस होता है जिसके जरिए ज़मीन का और दूसरी चीज़ों का लेवलिंग लिया जाता है। इस डिवाइस के मुख्य पार्ट्स हैं ये ट्राइपॉड स्टैंड में ये ट्राइपॉड स्क्रू होता है जिसके ज़रिए इसका हाइट एडजस्ट किया जाता है और हाइट के साथ साथ इसका लेवल भी एडजस्ट किया जाता है।
I belongs from Risu, Meghalaya. I first 10 class. My father is a farmer. He earns just rupees 200, 300 daily for family. There is not sufficient. I heard about my son training. Started at Risu Belpara by CIDC. I got admission and learning a lot about house construction. I learned about foundation, cement, sand, etc. By taking this training, I can make my future is better way. Thanks a lot to CIDC.
आफ्टर 10 पास में बेरोजगार था तो मेरा दोस्त राज ने बताया CIDC के बारे में और मैं CIDC सेंटर गोलाघाट ट्रेड प्लम्बर में ज्वाइन किया।
हम लोग गांव में कोई भी काम नहीं मिला, इसलिए हम लोग जो सेंटर से हम लोग को बोला, इसलिए वो लोग दिल्ली से सब लोग आया और ऋषि बेलपारा में अच्छा काम करना मिलेगा बोला, इसलिए हम लोग ट्रेनिंग के लिए CIDC के आया और हम लोग ये CIDC ट्रेनिंग खत्म होने के बाद हम अच्छा काम चुनेगा।
यहाँ मैं सिगोली CIDC सेंटर में फूड प्रिजर्वेशन में ट्रेड पे हम लोगों को आम के आसार, जाम, स्क्वायर बनाना सिखा रही है। तो यहाँ पे हम लोग यह बेल की स्क्वायर बना रही हूँ। तो ये सीखने के बाद हम लोग पैकेजिंग और मार्केटिंग भी सीखेंगे और सीख भी रही हूँ। और ये इसके लिए हमें तो फ्री में CIDC और AI हमें तो फ्री में ट्रेनिंग दे रही है। इसके लिए हम CIDC को और AAI को थैंक यू बोलना चाहती हूँ जो हम लोगों को फ्री में ट्रेनिंग दे रहे हैं। और मैं खुद ये सीखने के बाद मैं खुद के बिजनेस शुरू करूँगी, अगर मुझसे हो सके तो मैं जॉब भी करना चाहूँगी।
My father is a teacher. I'm taking training in Muslim trade at Nongstoin Center. I have learned about the construction material, measurement, the foundation, brick, masonry, extra from Pawan, from Sir Pawan. After training, I can work this trade and earn my living.
हम लोग अभी पहले तो हम लोग 200 रुपया ऐसा मांगेगा। अभी हम लोग CIDC ट्रेनिंग लेने के बाद हम लोग जो काम उसको हम लोग सीखेगा, उसको हम लोग अभी 500, 600, 700 ऐसा मांगेगा।
मैं असम से आई हूँ, मेरा डिस्ट्रिक्ट गोलाघाट। मैं पहले से गोलाघाट इंजीनियरिंग कॉलेज में CIDC पार्ट की सब्जेक्ट फूड प्रिजर्वेशन के लिए 3 मंथ की कोचिंग करने के लिए आई थी। वहाँ मैंने फूड प्रिजर्वेशन क्या है वो सीखा है। तो वहाँ का मैंने सिडोली सेंटर में ट्रांसफ़र की गई है। यहाँ पहला दिन से मैं आचार, जैम, जेली कैसे बनाती है वो सब सीखा है। और उसके बाद मैंने मार्केटिंग और पैकेजिंग भी बहुत सारी बातें सीखने के मिले हैं। तो इसीलिए मैं जो भी जॉब और ना तो मैं अपनी बिजनेस शुरू करना चाहती हूँ। सेंटर में फूड प्रिजर्वेशन का ट्रेनिंग ले रही हूँ। यहाँ पे हम प्रैक्टिकल कर रही हूँ। यहाँ पे हमें अचार बनाना, जाम बनाना, जेली बनाना आदि सिखाया गया है। और उसके साथ यहाँ पे मार्केटिंग और पैकेजिंग की भी सिखाया गया है। हम जॉब कर सकते हैं या जॉब नहीं भी करें तो उसके द्वारा हम अपना बिजनेस शुरू कर सकते हैं। इसीलिए मैं CIDC और AAI को धन्यवाद देना चाहती हूँ। वो हमें ये सिखाया कि हमें अपने पैरों पर खुद खड़ा होना सिखाया। इसलिए थैंक यू।
मैं CIDC में ट्रेनिंग करने के लिए आया हूँ जो कि बिनेश्वर इंजीनियरिंग कॉलेज में कराया जा रहा है, जो कि कोरल डिस्ट्रिक्ट में है, असम में। मैं जो ट्रेड लिया हुआ हूँ वो है जनरल वर्क सुपरवाइजर का।
ऑटो लेवल एक डिवाइस होता है जिसके जरिए लेवल जमीन का और दूसरी चीज़ों का लेवलिंग लिया जाता है। इस डिवाइस के मुख्य पार्ट्स हैं ये ट्राइपॉड स्टैंड में ये ट्राइपॉड स्क्रू होता है जिसके ज़रिए इसका हाइट एडजस्ट किया जाता है और हाइट के साथ साथ इसका लेवल भी एडजस्ट किया जाता है।
I belongs from Risu, Meghalaya. I first 10 class. My father is a farmer. He earns just rupees 200, 300 daily for family. There is not sufficient. I heard about my son training. Started at Day1 Part2 by CIDC. I got admission and learning a lot about house construction. I learn about foundation, cement, sand, etc. By taking this training, I can make my future is better way. Thanks a lot to CIDC.
आफ्टर 10 पास में बेरोजगार था तो मेरा दोस्त राज ने बताया CIDC के बारे में और मैं CIDC सेंटर गोलाघाट ट्रेड प्लम्बर में ज्वाइन किया।
हम लोग गांव में कोई भी काम नहीं मिला, इसलिए हम लोग जो सेंटर से हम लोग को बोला, इसलिए वो लोग दिल्ली से सब लोग आया और ऋषि वेलफेयर में अच्छा काम करना मिलेगा बोला, इसलिए हम लोग ट्रेनिंग के लिए CIDC के आया और हम लोग ये CIDC ट्रेनिंग खत्म होने के बाद हम अच्छा काम चुनेगा।
यहाँ मैं सिद्धौली CIDC सेंटर में फूड रिजर्वेशन में ट्रेड पे हम लोगों को आम के आसार, जाम, स्क्वायर बनाना सिखा रही है। तो यहाँ पे हम लोग ये बेलची स्क्वायर बना रही हूँ। तो ये सीखने के बाद हम लोग पैकेजिंग और मार्केटिंग भी सीखेंगे और सीख भी रही हूँ। और ये इसके लिए हमें तो फ्री में CIDC और AI हमें तो फ्री में ट्रेनिंग दे रही है। इसके लिए हम CIDC को और AAI को थैंक यू बोलना चाहती हूँ जो हम लोगों को फ्री में ट्रेनिंग दे रहे हैं। और मैं खुद ये सीखने के बाद मैं खुद के बिजनेस शुरू करूँगी, अगर मुझसे हो सके तो मैं जॉब भी करना चाहूँगी।
My father is a teacher. I'm taking training in Muslim Trade at Nongstoin Center. I have learned about the construction material, measurement, the foundation, brick, masonry, extra from Pawan, from South Pawan. After studying, I can work this trade and earn my living.
हम लोग अभी पहले तो हम लोग 200 रुपया ऐसा मांगेगा। अभी हम लोग CIDC ट्रेनिंग लेने के बाद हम लोग जो काम उसको हम लोग सीखेगा, उसको हम लोग अभी 500, 600, 700 ऐसा मांगेगा।
मैं असम से आई हूँ, मेरा डिस्ट्रिक्ट गोलाघाट। मैं पहले से गोलाघाट इंजीनियरिंग कॉलेज में CIDC पार्ट की सब्जेक्ट फूड प्रिजर्वेशन के लिए 3 मंथ की कोचिंग करने के लिए आई थी। वहाँ मैंने फूड प्रिजर्वेशन किया है, वो सीखा है। तो वहाँ पर मैंने सिद्धौली सेंटर में ट्रांसफ़र की गई है। यहाँ पहला दिन से मैं आचार, जैम, जेली कैसे बनाती है वो सब सीखा है। और उसके बाद मैंने मार्केटिंग और पैकेजिंग भी बहुत सारी बातें सीखने के मिले हैं। तो इसीलिए मैं जो भी जॉब और ना तो मैं अपनी बिजनेस शुरू करना चाहती हूँ। सेंटर में फूड प्रिजर्वेशन का ट्रेनिंग ले रही हूँ। यहाँ पे हम प्रैक्टिकल कर रही हूँ। यहाँ पे हमें अचार बनाना, जाम बनाना, जेली बनाना आदि सिखाया गया है। और उसके साथ यहाँ पे मार्केटिंग और पैकेजिंग की भी सिखाया गया है। हम जॉब कर सकते हैं या जॉब नहीं भी करें तो उसके द्वारा हम अपना बिजनेस शुरू कर सकते हैं। इसीलिए मैं CIDC और AAI को धन्यवाद देना चाहती हूँ। वो हमें ये सिखाया कि हमें अपने पैरों पर खुद खड़ा होना सिखाया। इसलिए थैंक यू।
मैं CIDC में ट्रेनिंग करने के लिए आया हूँ जो कि इंजीनियरिंग कॉलेज में कराया जा रहा है, जो कि कोराझर डिस्ट्रिक्ट में है, असम में। मैं जो ट्रेड लिया हुआ हूँ वो है जनरल वर्क सुपरवाइजर का।
ऑटो लेवल एक डिवाइस होता है जिसके जरिए जमीन का और दूसरी चीज़ों का लेवलिंग लिया जाता है। इस डिवाइस के मुख्य पार्ट्स हैं ये ट्राइपॉड स्टैंड में ये ट्राइपॉड स्क्रू होता है जिसके ज़रिए इसका हाइट एडजस्ट किया जाता है और हाइट के साथ साथ इसका लेवल भी एडजस्ट किया जाता है।
I belongs from Risu, Meghalaya. I first 10 class. My father is a farmer. He earns just rupees 300 daily for family. That is not sufficient. I heard about my son training. Started at Risu Welfare by CIDC. I got admission and learning a lot about house construction. I learned about foundation, cement, sand, etc. By taking this training, I can make my future is better way. Thanks a lot to CIDC.
आफ्टर 10 पास में बेरोजगार था तो मेरा दोस्त राज ने बताया CIDC के बारे में और मैं CIDC सेंटर गोलाघाट ट्रेड प्लम्बर में ज्वाइन किया।
हम लोग गांव में कोई भी काम नहीं मिला, इसलिए हम लोग जो सेंटर से हम लोग को बोला, इसलिए वो लोग दिल्ली से सब लोग आया और ऋषि वेलफेयर में अच्छा काम करना मिलेगा बोला, इसलिए हम लोग ट्रेनिंग के लिए CIDC के आया और हम लोग ये CIDC ट्रेनिंग खत्म होने के बाद हम अच्छा काम चुनेगा।
यहाँ मैं सिगोली CIDC सेंटर में खुद में ट्रेड करने पे हम लोगों को आम के आसार जाम स्क्वायर बनाना सिखा रही है। तो यहाँ पे हम लोग ये बेल की स्क्वायर बना रही हूँ। तो ये सीखने के बाद हम लोग पैकेजिंग और मार्केटिंग भी सीखेंगे और सीख भी रही हूँ। और ये इसके लिए हमें तो फ्री में CIDC और AI हमें तो फ्री में ट्रेनिंग दे रही है। इसके लिए हम CIDC को और AAI को थैंक यू बोलना चाहती हूँ, जो हम लोगों को फ्री में ट्रेनिंग दे रहे हैं। और मैं खुद ये सीखने के बाद मैं खुद के बिजनेस शुरू करूँगी, अगर मुझसे हो सके तो मैं जॉब भी करना चाहूँगी।
My father is a teacher. I'm taking training in Muslim Trade at Nongstoin Center. I have learned about the construction material, measurement, the foundation, brick, masonry, extra from Pawan, from South Pawan. After training, I can work this trade and earn my living.
हम लोग अभी पहले तो हम लोग 200 रुपया ऐसा मांगेगा। अभी हम लोग CIDC ट्रेनिंग लेने के बाद हम लोग जो काम उसको हम लोग सीखेगा, उसको हम लोग अभी 500, 600, 700 ऐसा मांगेगा।
मैं असम से आई हूँ, मेरा डिस्ट्रिक्ट गोलाघाट। मैं पहले से गोलाघाट इंजीनियरिंग कॉलेज में CIDC पार्ट की सब्जेक्ट फूड प्रिजर्वेशन के लिए 3 मंथ की कोचिंग करने के लिए आई थी। वहाँ मैंने फूड प्रिजर्वेशन क्या है वो सीखा है। तो वहाँ पर मैंने सिडोली सेंटर में ट्रांसफ़र की गई है। यहाँ पहला दिन से मैं आचार, जैम, जेली कैसे बनाती है वो सब सीखा है। और उसके बाद मैंने मार्केटिंग और पैकेजिंग भी बहुत सारी बातें सीखने के मिले हैं। तो इसीलिए मैं जो भी जॉब और ना तो मैं अपनी बिजनेस शुरू करना चाहती हूँ। सेंटर में फूड प्रिजर्वेशन का ट्रेनिंग ले रही हूँ। यहाँ पे हम प्रैक्टिकल कर रही हूँ। यहाँ पे हमें अचार बनाना, जाम बनाना, जेली बनाना आदि सिखाया गया है। और उसके साथ यहाँ पे मार्केटिंग और पैकेजिंग की भी सिखाया गया है। हम जॉब कर सकते हैं या जॉब नहीं भी करें तो उसके द्वारा हम अपना बिजनेस शुरू कर सकते हैं। इसीलिए मैं CIDC और AAI को धन्यवाद देना चाहती हूँ। वो हमें ये सिखाया कि हमें अपने पैरों पर खुद खड़ा होना सिखाया। इसलिए थैंक यू।
मैं CIDC में ट्रेनिंग करने के लिए आया हूँ, जो कि बिनेश्वर इंजीनियरिंग कॉलेज में कराया जा रहा है, जो कि कोराझर डिस्ट्रिक्ट में है, असम में। मैं जो ट्रेड लिया हुआ हूँ वो है जनरल वर्क सुपरवाइजर का।
ऑटो लेवल एक डिवाइस होता है जिसके जरिए जमीन का और दूसरी चीज़ों का लेवलिंग लिया जाता है। इस डिवाइस के मुख्य पार्ट्स हैं ये ट्राइपॉड स्टैंड में ये ट्राइपॉड स्क्रू होता है जिसके ज़रिए इसका हाइट एडजस्ट किया जाता है और हाइट के साथ साथ इसका लेवल भी एडजस्ट किया जाता है।
I belongs from Risu, Meghalaya. I first 10 class. My father is a farmer. He earns just rupees 300 daily for family. That is not sufficient. I heard about my son training. Started at Risu Welfare by CIDC. I got admission and learning a lot about house construction. I learned about foundation, cement, sand, etc. By taking this training, I can make my future is better way. Thanks a lot to CIDC.
आफ्टर 10 पास में बेरोजगार था तो मेरा दोस्त राज ने बताया CIDC के बारे में और मैं CIDC सेंटर गोलाघाट ट्रेड प्लम्बर में ज्वाइन किया।
हम लोग गांव में कोई भी काम नहीं मिला, इसलिए हम लोग जो सेंटर से हम लोग को बोला, इसलिए वो लोग दिल्ली से सब लोग आया और ऋषि वेलफेयर में अच्छा काम करना मिलेगा बोला, इसलिए हम लोग ट्रेनिंग के लिए CIDC के आया और हम लोग ये CIDC ट्रेनिंग खत्म होने के बाद हम अच्छा काम चुनेगा।
यहाँ मैं सिगोली CIDC सेंटर में फूड रिजर्वेशन में ट्रेड पे हम लोगों को आम के आचार, जाम, स्क्वायर बनाना सिखा रही है। तो यहाँ पे हम लोग यह बेलची स्क्वायर बना रही हूँ। तो ये सीखने के बाद हम लोग पैकेजिंग और मार्केटिंग भी सीखेंगे और सीख भी रही हूँ। और ये इसके लिए हमें तो फ्री में CIDC और AI हमें तो फ्री में ट्रेनिंग दे रही है। इसके लिए हम CIDC को और AI को थैंक यू बोलना चाहती हूँ, जो हम लोगों को फ्री में ट्रेनिंग दे रहे हैं। और मैं खुद ये सीखने के बाद मैं खुद के बिजनेस शुरू करूँगी। अगर मुझसे हो सके तो मैं जॉब भी करना चाहूँगी।
My father is a teacher. I'm taking training in Muslim Trade at Nongstoin Center. I have learned about the construction material, measurement, the foundation, brick, masonry, extra from Pawan, from South Pawan. After training, I can work this trade and earn my living.
हम लोग अभी पहले तो हम लोग 200 रुपया ऐसा मांगेगा। अभी हम लोग CIDC ट्रेनिंग लेने के बाद हम लोग जो काम उसको हम लोग सीखेगा, उसको हम लोग अभी 500, 600, 700 ऐसा मांगेगा।
मैं असम से आई हूँ, मेरा डिस्ट्रिक्ट गोलाघाट। मैं पहले से गोलाघाट इंजीनियरिंग कॉलेज में CIDC पार्ट की सब्जेक्ट फूड प्रिजर्वेशन के लिए 3 मंथ की कोचिंग करने के लिए आई थी। वहाँ मैंने फूड प्रिजर्वेशन क्या है वो सीखा है। तो वहाँ का मैंने सिडोली सेंटर में ट्रांसफ़र की गई है। यहाँ पहला दिन से मैं आचार, जैम्स, जेली कैसे बनाती है वो सब सीखा है। और उसके बाद मैंने मार्केटिंग और पैकेजिंग भी बहुत सारी बातें सीखने के मिले हैं। तो इसीलिए मैं जो भी जॉब और ना तो मैं अपनी बिजनेस शुरू करना चाहती हूँ। सेंटर में फूड प्रिजर्वेशन का ट्रेनिंग ले रही हूँ। यहाँ पे हम प्रैक्टिकल कर रही हूँ। यहाँ पे हमें अचार बनाना, जाम बनाना, जेली बनाना आदि सिखाया गया है। और उसके साथ यहाँ पे मार्केटिंग और पैकेजिंग की भी सिखाया गया है। हम जॉब कर सकते हैं या जॉब नहीं भी करें तो उसके द्वारा हम अपना बिजनेस शुरू कर सकते हैं। इसीलिए मैं CIDC और AI को धन्यवाद देना चाहती हूँ। वो हमें ये सिखाया कि हमें अपने पैरों पर खुद खड़ा होना सिखाया। इसलिए थैंक यू।
मैं CIDC में ट्रेनिंग करने के लिए आया हूँ, जो कि बिनेश्वर ब्रह्मो इंजीनियरिंग कॉलेज में कराया जा रहा है, जो कि कोरल डिस्ट्रिक्ट में है, असम में। मैं जो ट्रेड लिया हुआ हूँ वो है जनरल वर्क सुपरवाइजर का।
ऑटो लेवल एक डिवाइस होता है जिसके जरिए जमीन का और दूसरी चीज़ों का लेवलिंग लिया जाता है। इस डिवाइस के मुख्य पार्ट्स हैं ये ट्राइपॉड स्टैंड में ये ट्राइपॉड स्क्रू होता है जिसके ज़रिए इसका हाइट एडजस्ट किया जाता है और हाइट के साथ साथ इसका लेवल भी एडजस्ट किया जाता है।
I belongs from Risu, Meghalaya. I first 10 class. My father is a farmer. He earns just rupees 200, 300 daily for family. That is not sufficient. I heard about my son training. Started at Risu Velpara by CIDC. I got admission and learning a lot about house construction. I learned about foundation, cement, sand, etc. By taking this training, I can make my future is better way. Thanks a lot to CIDC.
आफ्टर 10 पास में बेरोजगार था तो मेरा दोस्त राज ने बताया CIDC के बारे में। और मैं CIDC सेंटर गोलाघाट ट्रेड प्लम्बर में ज्वाइन किया।
हम लोग गांव में कोई भी काम नहीं मिला, इसलिए हम लोग जो सेंटर से हम लोग को बोला, इसलिए वो लोग दिल्ली से सब लोग आया और ऋषि वेलफेयर में अच्छा काम करना मिलेगा बोला, इसलिए हम लोग ट्रेनिंग के लिए CIDC के आया। और हम लोग ये CIDC ट्रेनिंग खत्म होने के बाद हम अच्छा काम चुनेगा।
यहाँ मैं सिगोली CIDC सेंटर में फूड रिजर्वेशन में ट्रेड पे हम लोगों को आम के आचार, जाम, स्क्वायर बनाना सिखा रही है। तो यहाँ पे हम लोग यह बेलची स्क्वायर बना रही हूँ। तो ये सीखने के बाद हम लोग पैकेजिंग और मार्केटिंग भी सीखेंगे और सीख भी रही हूँ। और इसके लिए हमें तो फ्री में CIDC और AI हमें तो फ्री में ट्रेनिंग दे रही है। इसके लिए हम CIDC को और AAI को थैंक यू बोलना चाहते हूँ, जो हम लोगों को फ्री में ट्रेनिंग दे रहे हैं। और मैं खुद ये सीखने के बाद मैं खुद के बिजनेस शुरू करूँगी। अगर मुझसे हो सके तो मैं जॉब भी करना चाहूँगी।
My father is a teacher. I'm taking training in Muslim Trade at Nongstoin Center. I have learned about the construction material, measurement, the foundation, brick, masonry, extra from Pawan, from South Pawan. After training, I can work this trade and earn my living.
हम लोग अभी पहले तो हम लोग 200 रुपया ऐसा मांगेगा। अभी हम लोग से ट्रेनिंग लेने के बाद हम लोग जो काम उसको हम लोग सीखेगा, उसको हम लोग अभी 500, 600, 700 ऐसा मांगेगा।
मैं असम से आई हूँ, मेरा डिस्ट्रिक्ट गोलाघाट। मैं पहले से गोलाघाट इंजीनियरिंग कॉलेज में CIDC पार्ट की सब्जेक्ट फूड प्रिजर्वेशन के लिए 3 मंथ की कोचिंग करने के लिए आई थी। वहाँ मैंने फूड प्रिजर्वेशन क्या है वो सीखा है। तो वहाँ पर मैंने सिडोली सेंटर में ट्रांसफ़र की गई है। यहाँ पहला दिन से मैं अचार, जैम, जेली कैसे बनाती है वो सब सीखा है। और उसके बाद मैंने मार्केटिंग और पैकेजिंग भी बहुत सारी बातें सीखने के मिले हैं। तो इसीलिए मैं जो भी जॉब और ना तो मैं अपनी बिजनेस शुरू करना चाहती हूँ। सेंटर में फूड प्रिजर्वेशन का ट्रेनिंग ले रही हूँ। यहाँ पे हम प्रैक्टिकल कर रही हूँ। यहाँ पे हमें अचार बनाना, जाम बनाना, जेली बनाना आदि सिखाया गया है। और उसके साथ यहाँ पे मार्केटिंग और पैकेजिंग की भी सिखाया गया है। हम जॉब कर सकते हैं या जॉब नहीं भी करें तो उसके द्वारा हम अपना बिजनेस शुरू कर सकते हैं। इसीलिए मैं CIDC और AAI को धन्यवाद देना चाहती हूँ। वो हमें ये सिखाया कि हमें अपने पैरों पे खुद खड़ा होना सिखाया। इसलिए थैंक यू।
मैं CIDC में ट्रेनिंग करने के लिए आया हूँ, जो कि मिनेश्वर इंजीनियरिंग कॉलेज में कराया जा रहा है, जो कि कोराझर डिस्ट्रिक्ट में है, असम में। मैं जो ट्रेड लिया हुआ हूँ वो है जनरल वर्क सुपरवाइजर का।
ऑटो लेवल एक डिवाइस होता है जिसके जरिए ज़मीन का और दूसरी चीज़ों का लेवलिंग लिया जाता है। इस डिवाइस के मुख्य पार्ट्स हैं ये ट्राइपॉड स्टैंड में ये ट्राइपॉड स्क्रू होता है जिसके ज़रिए इसका हाइट एडजस्ट किया जाता है और हाइट के साथ साथ इसका लेवल भी एडजस्ट किया जाता है।
I belongs from Risu, Meghalaya. I first 10 class. My father is a farmer. He earns just rupees 200, 300 daily for family. There is not sufficient. I heard about my son training. Started at Risu Welfare by CIDC. I got admission and learning a lot about house construction. I learned about foundation, cement, sand, etc. By taking this training, I can make my future is better way. Thanks a lot to CIDC.
आफ्टर 10 पास में बेरोजगार था तो मेरा दोस्त राज ने बताया CIDC के बारे में। और मैं CIDC सेंटर गोलाघाट ट्रेड प्लम्बर में ज्वाइन किया।
हम लोग गांव में कोई भी काम नहीं मिला, इसलिए हम लोग जो सेंटर से हम लोग को बोला, इसलिए वो लोग दिल्ली से सब लोग आया और ऋषि वेलफेयर में अच्छा काम करना मिलेगा बोला, इसलिए हम लोग ट्रेनिंग के लिए CIDC के आया। और हम लोग ये CIDC ट्रेनिंग खत्म होने के बाद हम अच्छा काम चुनेगा।
यहाँ मैं सिडोली CIDC सेंटर में फूड प्रिजर्वेशन में ट्रेड पे हम लोगों को आम के अचार, जाम, स्क्वायर बनाना सिखा रही है। तो यहाँ पे हम लोग यह बेल की स्क्वायर बना रही हूँ। तो ये सीखने के बाद हम लोग पैकेजिंग और मार्केटिंग भी सीखेंगे और सीख भी रही हूँ। और ये इसके लिए हमें तो फ्री में CIDC और AAI हमें तो फ्री में ट्रेनिंग दे रही है। इसके लिए हम CIDC को और AAI को थैंक यू बोलना चाहते हूँ, जो हम लोग को फ्री में ट्रेनिंग दे रहे हैं। और मैं खुद ये सीखने के बाद मैं खुद के बिजनेस शुरू करूँगी। अगर मुझसे हो सके तो मैं जॉब भी करना चाहूँगी।
My father is a teacher. I'm taking training in Muslim Trade at Nongstoin Center. I have learned about the construction material, measurement, the foundation, brick, machinery extra from Pawan, from Sir Pawan. After studying, I can work this trade and earn my living.
हम लोग अभी पहले तो हम लोग 200 रुपया ऐसा मांगेगा। अभी हम लोग CIDC ट्रेनिंग लेने के बाद हम लोग जो काम उसको हम लोग सीखेगा, उसको हम लोग अभी 500, 600, 700 ऐसा मांगेगा।
मैं असम से आई हूँ, मेरा डिस्ट्रिक्ट गोलाघाट। मैं पहले से गोलाघाट इंजीनियरिंग कॉलेज में CIDC पार्ट की सब्जेक्ट फूड प्रिजर्वेशन के लिए 3 मंथ की कोचिंग करने के लिए आई थी। वहाँ मैंने फूड प्रिजर्वेशन क्या है वो सीखा है। तो वहाँ पर मैंने सिडोली सेंटर में ट्रांसफ़र की गई है। यहाँ पहला दिन से मैं अचार, जैम, जेली कैसे बनाती है वो सब सीखा है। और उसके बाद मैंने मार्केटिंग और पैकेटिंग भी बहुत सारी बातें सीखने के मिले हैं। तो इसीलिए मैं जो भी जॉब और ना तो मैं अपनी बिजनेस शुरू करना चाहती हूँ। सेंटर में फूड प्रिजर्वेशन का ट्रेनिंग ले रही हूँ। यहाँ पे हम प्रैक्टिकल कर रही हूँ। यहाँ पे हमें अचार बनाना, जाम बनाना, जेली बनाना आदि सिखाया गया है। और उसके साथ यहाँ पे मार्केटिंग और पैकेजिंग की भी सिखाया गया है। हम जॉब कर सकते हैं या जॉब नहीं भी करें तो उसके द्वारा हम अपना बिजनेस शुरू कर सकते हैं। इसीलिए मैं CIDC और AI को धन्यवाद देना चाहती हूँ। वो हमें ये सिखाया कि हमें अपने पैरों पर खुद खड़ा होना सिखाया। इसलिए थैंक यू।
मैं CIDC में ट्रेनिंग करने के लिए आया हूँ, जो कि बिनेश्वर इंजीनियरिंग कॉलेज में कराया जा रहा है, जो कि कोरल डिस्ट्रिक्ट में है, असम में। मैं जो ट्रेड लिया हुआ हूँ वो है जनरल वर्क सुपरवाइजर का।
ऑटो लेवल एक डिवाइस होता है जिसके जरिए जमीन का और दूसरी चीज़ों का लेवलिंग लिया जाता है। इस डिवाइस के मुख्य पार्ट्स हैं ये ट्राइपॉड स्टैंड में ये ट्राइपॉड स्क्रू होता है जिसके ज़रिए इसका हाइट एडजस्ट किया जाता है और हाइट के साथ साथ इसका लेवल भी एडजस्ट किया जाता है।
I belongs from Risu, Meghalaya. I first 10 class. My father is a farmer. He earns just rupees 200, 300 daily for family. There is not sufficient. I heard about my son training. Started at Risu Welfare by CIDC. I got admission and learning a lot about house construction. I learned about foundation, cement, sand, etc. By taking this training, I can make my future is better way. Thanks a lot to CIDC.
आफ्टर 10 पास में बेरोजगार था तो मेरा दोस्त राज ने बताया CIDC के बारे में। और मैं CIDC सेंटर गोलाघाट ट्रेड प्लम्बर में ज्वाइन किया।
हम लोग गांव में कोई भी काम नहीं मिला, इसलिए हम लोग जो सेंटर से हम लोग को बोला, इसलिए वो लोग दिल्ली से सब लोग आया और ऋषि वेलफेयर में अच्छा काम करना मिलेगा बोला, इसलिए हम लोग ट्रेनिंग के लिए CIDC के आया। और हम लोग ये CIDC ट्रेनिंग खत्म होने के बाद हम अच्छा काम चुनेगा।
यहाँ मैं सिडोली CIDC सेंटर में फूड प्रिजर्वेशन में ट्रेड पे हम लोगों को आम के अचार, जाम, स्क्वायर बनाना सिखा रही है। तो यहाँ पे हम लोग यह बेलची स्क्वायर बना रही हूँ। तो ये सीखने के बाद हम लोग पैकेजिंग और मार्केटिंग भी सीखेंगे और सीख भी रही हूँ। और ये इसके लिए हमें तो फ्री में CIDC और AI हमें तो फ्री में ट्रेनिंग दे रही है। इसके लिए हम CIDC को और AI को थैंक यू बोलना चाहती हूँ जो हम लोगों को फ्री में ट्रेनिंग दे रहे हैं। और मैं खुद ये सीखने के बाद मैं खुद के बिजनेस शुरू करूँगी। अगर मुझसे हो सके तो मैं जॉब भी करना चाहूँगी।
My father is a teacher. I'm taking training in Muslim trade at Nongstoin Center. I have learned about the construction material, measurement, the foundation, brick, machinery, extra from Pawan, from Sir Pawan. After studying, I can work this trade and earn my living.
हम लोग अभी पहले तो हम लोग 200 रुपया ऐसा मांगेगा। अभी हम लोग CIDC ट्रेनिंग लेने के बाद हम लोग जो काम उसको हम लोग सीखेगा, उसको हम लोग अभी
500 600 700 ऐसा मांगेगा।
मैं आसाम से आई हूँ, मेरा डिस्ट्रिक्ट गोलाघाट। मैं पहले से गोलाघाट इंजीनियरिंग कॉलेज में CIDC पार्ट की सब्जेक्ट फूड प्रिजर्वेशन के लिए 3 मंथ की कोचिंग करने के लिए आई थी। वहाँ मैंने फूड प्रिजर्वेशन क्या है वो सीखा है। तो वहाँ का मैंने सिडोली सेंटर में ट्रांसफ़र की गई है। यहाँ पहला दिन से मैं आचार, जैम्स, जेली कैसे बनाती है वो सब सीखा है। और उसके बाद मैंने मार्केटिंग और पैकेजिंग भी बहुत सारी बातें सीखने के मिले हैं। तो इसीलिए मैं जो भी जॉब और ना तो मैं अपनी बिजनेस शुरू करना चाहती हूँ। सेंटर में फूड प्रिजर्वेशन का ट्रेनिंग ले रही हूँ। यहाँ पे हम प्रैक्टिकल कर रही हूँ। यहाँ पे हमें अचार बनाना, जाम बनाना, जेली बनाना आदि सिखाया गया है। और उसके साथ यहाँ पे मार्केटिंग और पैकेजिंग की भी सिखाया गया है। हम जॉब कर सकते हैं या जॉब नहीं भी करें तो उसके द्वारा हम अपना बिजनेस शुरू कर सकते हैं। इसीलिए मैं CIDC और AI को धन्यवाद देना चाहती हूँ। वो हमें ये सिखाया, या हमें अपने पैरों पर खुद खड़ा होना सिखाया। इसलिए थैंक यू।
मैं CIDC में ट्रेनिंग करने के लिए आया हूँ, जो कि मिनेश्वर ब्रह्मो इंजीनियरिंग कॉलेज में कराया जा रहा है, जो कि कोरल डिस्ट्रिक्ट में है, असम में। मैं जो ट्रेड लिया हुआ हूँ वो है जनरल वर्क सुपरवाइजर का।
ऑटो लेवल एक डिवाइस होता है जिसके जरिए जमीन का और दूसरी चीज़ों का लेवलिंग लिया जाता है। इस डिवाइस के मुख्य पार्ट्स हैं ये ट्राइपॉड स्टैंड में ये ट्राइपॉड स्क्रू होता है जिसके ज़रिए इसका हाइट एडजस्ट किया जाता है और हाइट के साथ साथ इसका लेवल भी एडजस्ट किया जाता है।
I belongs from Risu, Meghalaya. I first 10 class. My father is a farmer. He earns just rupees 300 daily for family. That is not sufficient. I heard about my son training. Started at Risu Welfare by CIDC. I got admission and learning a lot about house construction. I learned about foundation, cement, sand, etc. By taking this training, I can make my future is better way. Thanks a lot to CIDC.
आफ्टर 10 पास में बेरोजगार था तो मेरा दोस्त राज ने बताया CIDC के बारे में। और मैं CIDC सेंटर गोलाघाट ट्रेड प्लम्बर में ज्वाइन किया।
हम लोग गांव में कोई भी काम नहीं मिला, इसलिए हम लोग जो सेंटर से हम लोग को बोला, इसलिए वो लोग दिल्ली से सब लोग आया और ऋषि वेलफेयर में अच्छा काम करना मिलेगा बोला, इसलिए हम लोग ट्रेनिंग के लिए CIDC के आया। और हम लोग ये CIDC ट्रेनिंग खत्म होने के बाद हम अच्छा काम चुनेगा।
यहाँ मैं सिडोली CIDC सेंटर में फूड प्रिजर्वेशन में ट्रेड पे हम लोगों को आम के अचार, जाम, स्क्वायर बनाना सिखा रही है। तो यहाँ पे हम लोग यह बेलची स्क्वायर बना रही हूँ। तो ये सीखने के बाद हम लोग पैकेजिंग और मार्केटिंग भी सीखेंगे और सीख भी रही हूँ। और ये इसके लिए हमें तो फ्री में CIDC और AI हमें तो फ्री में ट्रेनिंग दे रही है। इसके लिए हम CIDC को और AI को थैंक यू बोलना चाहती हूँ, जो हम लोग को फ्री में ट्रेनिंग दे रहे हैं। और मैं खुद ये सीखने के बाद मैं खुद के बिजनेस शुरू करूँगी। अगर मुझसे हो सके तो मैं जॉब भी करना चाहूँगी।
My father is a teacher.
group, a self-help group called the Sewer Rehabilitation Contact Group, which has representatives from the UK's 12 regional sewer network owners and also from Irish Water in the Republic of Ireland. So in this webinar, I'm going to be reviewing the general response so far, identifying lessons learned and considering what next. It's in 4 parts, setting the scene where we are, what's been learned about preparing for the pandemic, what's been learned about reacting to the pandemic, and some thoughts about what happens next with the recovery from the pandemic. Well, what happened with the Komnet Abwasser, perhaps typical of many organisations, we had a meeting. This in the picture is the last meeting before lockdown, and all subsequent meetings have been online. They focused on 3 things then. How was the disease and the virus transmitted? What role did water and sanitation play, and what do they need to worry about concerning occupational health and safety? And from that first meeting, they agreed 3 principles. They had to be very careful about the occupational safety for their staff, avoid unnecessarily risks, but concluded on the evidence available that if they applied the usual hygiene regulations that apply to working around sewage, then that should be sufficient for the moment. It was the last time they met together, as I said, and they then did 4 things subsequently. They regularly discussed and shared plans with each other of how they were coping with the pandemic. They made a decision to open up their discussions to other sewer network owners and also to publish information in English. So we did a series of 3 English language webinars to widen awareness. The members started sharing their documents online, and if you search for Komnet Abwasser, you will find, it's in German, you'll find the information they shared with each other, and IKT provided a help desk for them. Now, as I mentioned, fairly typical of actions taken by associations throughout the world to help their members. Initially, everybody was searching for the answers to how is this going to pan out? How does this virus behave? And it was the World Health Organization that, not surprisingly, emerged as the primary source of information. Also, the national bodies responsible for public health provided useful guidance. And as time has gone by, there's been a lot more information available, but during those initial stages, self-help was really the only way forward. So, if we look at the questions that have been asked over this year of trade associations by their water company members, in the early days they were mostly surrounding the transmission, the risk, and health and safety. Also, what to prioritize, what work could they give up, and what work should they continue with, how to organize their staff. And as regulatory requirements kept changing, a lot of questions out there about what this meant. By the middle of this year, the concern was more about availability of personal protective equipment. And then subsequently, it's been shifting, not surprisingly, towards impacts on revenue, what financial support is available to water utilities, and what's going to be the consequence for their operations in the future. Well, going back to what was initially known, the exact behavior of the SARS-CoV-2 virus was unknown. And to be honest, we're still discovering a lot of information about it. So all the initial deductions had to be based upon other coronaviruses and what was known. And so assumptions initially had to be made about the risks for water and sewage, and subsequently they proved correct. So that provides some reassurance that collectively we'll be able to respond quickly to the next pandemic when it comes along. Now, we looked around for guidance and advice, and actually one of the most comprehensive guides we found was a checklist that's been produced by the US Environment Protection Agency. It's their incident accident checklist for pandemic incidents, and that divided up the actions into 3 stages: preparing for the pandemic, responding to a pandemic, and recovering from it. So preparing, in a way, it's still ongoing because situations change and national regulations change. So there's those have to be thought through. But mostly what is happening at the moment is responding to the pandemic. We're not in a recovery phase yet. So when I say we're not in the recovery phase yet, we still really don't know how this is going to pan out. So we're in stage 2. We don't have vaccines commonly available yet. There is no cure. And further waves of infection are expected. Now, it wasn't known initially what it was going to look like. It appears, certainly from what was happening at the moment in the UK and Germany, that we're in this situation here. We're somewhere on the rise in a major winter spike. And we do not know, going forward, without intervention, how this is going to turn out. So, looking at preparing for the pandemic, there's 5 actions here which summarize, and these are the principal actions again from that EPA document, what needs to be done. Planning the response, i.e. organizing the teams, organizing the staff, organizing the way forward, ensuring employees are protected, maintaining essential operations. How are the essential operations going to be identified and continue to operate? What were the key facilities that had to be maintained? And how was the communication to be conducted for all of this, bearing in mind that there were all these restrictions moving in? And what's covered in the next slides applies equally to the water companies as it does to the supply chain, including the trenchless technology providers. Well, the typical planning actions: creating a team to lead the response, updating the response plans. Now, really, nobody's response plans, which existed, really anticipated exactly what was going to happen in terms of lockdowns, shutting downs of business, disruptions to the supply chain, and for many businesses, losing all of their income overnight. Reviews of information technology, the hardware, the software, how we're going to communicate, and also just ensuring how your staff are going to be able to continue to work under national regulations, for example, what counted as being essential services. Now, when it came to protecting employee health, you need to review your existing rules, ensure personal hygiene, ensure the supply of protective equipment, but particularly checking all the way through that the employees understood what they had to do. And for those who didn't have to be out there in public contact or working in the field, arranging home working and other social distancing measures became important. For us managing essential operations, it was a case of identifying what jobs needed to be staffed in order to keep the operations running. What were the critical activities that had to be undertaken? Also, who are the critical customers? The hospitals and other facilities that absolutely had to be kept online for supply of water and wastewater. And then finally, supporting all of that was finding alternative staff. So trawling through the staff in water companies and others who perhaps had past experience of running pumping systems or running a treatment works or a distribution network, who perhaps now are doing just jobs but might be available to be pulled back if needed. And when it came to the facilities, clearly there's pumps, tankers, valves, etc., which need to be maintained, but also what equipment was needed to maintain them, what supplies were needed. So there's a lot of activity, of course, as we know, around working with suppliers, developing the systems and finding alternative sources and creating stockpiles if necessary. So continuing with the theme of stage 1, the final element of that was the communication. So what needs to be communicated to customers and others, and how to set up those. And particularly, I think one of the main lessons that came out of this was a realization that perhaps traditional ways of raising revenue or collecting revenue from customers would have to change, and that online payment was perhaps going to have to be created as the new norm. Well, when we look at then about how there was a response to the pandemic, we've covered several of those items as well. So the plans are in place. So now it's all about protecting your employees' health, maintaining the operations and facilities, doing the communication. But there was also an important one, was actually recording what went on, particularly for those water companies that are in a heavy regulatory regime in terms of finance or environmental protection or performance in terms of customer complaints. They needed to really understand what happened so that they could subsequently argue the case with regulators if there were likely to be penalties for what had taken place. So this is the sort of stage where most of the sewer network operators are currently at. And when we look at a key issue that actually cropped up for many organizations was actually getting their staff recognized as being essential workers. And this wasn't recognized everywhere. So you have guys out trying to maintain water and sewer supplies getting stopped by the police. You get angry reactions from the public, seeing people working in the road saying, you're going to give us this disease, what are you doing here? And having to explain to them that actually it was essential that their water and their sewerage was maintained. And then in many cases as well, it was necessary to be an essential worker in order for staff to be able to work if there was childcare or free movement or even testing services available for essential workers only. So when it came to protecting the health of staff, these are the sorts of things that were going on: outside team meetings for field staff, for office staff, one man per vehicle, or having two men on a vehicle, but keeping the vehicles separated and the team separated, so one lot went down with the disease, others wouldn't, and maintaining social distancing rules when working. In offices and in laboratories, the same thing, having to maintain the distance. And right down to a couple of pictures from IKT here, we were able to maintain some training, but reduced numbers of people and distance between them, and a very simple ruse here on the right to ensure that only one person was using the conveniences at a time. Now, keeping staff informed about the risks cropped up. Partway through the year, it was announced in the press that it was going to be possible to test for coronavirus in sewage because coronavirus had been found in sewage. Now, this caused consternation, and right across Europe, trade associations and others are having to deal with concerned staff and their families, saying, what's all this about coronavirus being in sewage? Unfortunately, what had happened was the initial press releases had not explained that it was just the genetic material found, not the live virus. And that caused quite a lot of trouble. Of course, I touched upon what happened with PPE. Nobody had enough, there were shortages, it was discovered the supply chain was fragile and that the existing reserves were not robust. So a lot of lessons learned there for future pandemics. Now, an issue and really interesting development, of course, was home working. There were issues to start with, what hardware to use, what software to use, whether there are any human resource or health and safety issues. But actually, a lot of staff have discovered that they like working from home and were able to continue to work from home and do their roles. They have fewer interruptions. And actually, there are a number of studies out there which have shown that productivity and innovation actually can improve with people working from home. There's a reduction in office costs, but some equipment costs for equipping people to work from home. But the really big thing I think that has come out of it is this online communication, surge in use. Now, the water sector is pretty conservative, and over the years, many people have been trying to say, let's communicate online rather than having to have endless meetings and traveling halfway across the country in order to have sales meetings and project meetings. But they've actually discovered, most water companies, that it works well. The communications are faster. There's also, for them, a pleasing reduction in costs for conducting meetings, for traveling, for training. So when we go back to the operations themselves, some water and sewage companies manage to maintain activities and some reduce them. It depends a lot on the national rules. The things which are stopped tend to be the routine maintenance and investment works, including some sewer rehabilitation work. And what had to be maintained was urgent maintenance, blockages and collapses. So there were some trenchless technologies became important there. And there were design tasks which could be still undertaken, which were office-based. Now, looking particularly at contractors and what has happened there is that in some cases contractors haven't been able to work or they've had to reduce their active staff. But there's been a sort of a knock-on impact has been felt with in terms of contractual arrangements, a sort of more flexibility on both sides, contractors and clients. Better ways of dealing with deadlines, not applying financial penalties for delays, extensions to delivery times, consequences, financial and otherwise, of delays, more interruptions allowed or suspension of work. But there has been some postponement of tenders or offers during the period. Critical for the water and sewage companies themselves, though, is what's happened with their funding. Around the world, customers got mixed messages. So water companies have been instructed variously by governments not to increase charges or to reduce charges, to defer payments, or even make water free, and no mandatory reconnection. So there's been a reduced incentive of customers to pay. And then there have been changes to revenue. So commercial and industrial revenue dropped during closures, domestic revenue went up. If you are a water company in a city, no commuters, no tourists. In the rural areas, more domestic use from people staying at home, but less tourists. So different impacts felt in different places. And there's been this need for new methods of payment. So you can't have people visiting offices, making face-to-face payments. Cash payment became difficult. Access to banks has been difficult. And so new systems are needed with the online systems. Online banking, there's been a surprising increase in that throughout all around the world. And but of course, customers do need to be encouraged to pay. The impact has been interesting. The World Bank recently reported that a 10 to 40% reduction in revenues, and as high as 70 to 80% in case of some of the water companies that they were dealing with. So they've created spreadsheet tools. Latin American bank has had a similar experience. And in Europe, the Acqua Pubblica Europa, which is a trade association dealing with publicly funded water and sewage companies, said their members have reported a 10 to 15% reduction in income. And as a consequence, having to stop part or all of investment. So what's the result of that has been that in many countries, the trade associations representing the sectors have been raising issues of financial support on behalf of their members. Public finances are going to be under strain for some years to come. So it's apparent that water and sewage companies are going to have to find ways of smarter ways of delivering their services for less money. And of course, trenchless technology has some advantages here. I've mentioned communication with regulators and keeping records. That's been a key as well, a lesson learned. So particularly if you've got activities that had to be stopped, you had to keep them informed, keeping them aware of issues. And that's another place where trade associations have been important, working on behalf of their members to raise such issues and deal with authorities collectively. So going on this theme of associations and what has happened there, with the current situation, it's really highlighted that associations have a role to play if there is a change in advice relating to transmission. They've got a really good job to play for their members in signposting changes in national regulation, lobbying government and regulators on behalf of members about public health, financial support, environmental regulation. And last but not least, providing access to experts who can give the advice that is needed. And what's been fundamental to that Well, embracing of online communication, such as we're doing today. You can't hold face-to-face meetings. Online is likely to become the new normal. Working from home is now acceptable. You can now undertake meetings daily, weekly, or monthly. So in Germany, the Communat Abwasser now meets every Friday. And in the UK, the Sewer Rehab Contact Group, which met 3 times a year, now meets every month online. But the converse side is that conference organisers are experiencing problems with events. So major events like the German IFAT exhibition should have taken place this year. It's now not going to take place until 2 years' time when otherwise expected. And in the UK STT, its annual No Dig event was put back from September to next March, and it's now being put back from next March to June. And a major outcome, I think, is going to be we're going to see more automation and remote working on sewer networks. And this is where all companies have the opportunity to learn from each other nationally and internationally. There's going to be a lot of innovation and development, and basically water and sewage companies are going to be more receptive to new ideas. What next? This is the final slide. The situation's still evolving. The disruption is going to be long term. There's a lot more information and data that's going to emerge. So keeping an eye on what's going on internationally and nationally is going to be important. Creating or joining networks of organizations which can answer questions of mutual interest is probably the best way forward. That has really emerged from the lessons learned from this pandemic so far. And different countries are at different stages, so there's a lot to learn, therefore, from each other. So we talk of a new normal when this is over, after the pandemic. The new normal is already here. It's coping with the pandemic whilst having to make tough decisions about water industry investment and operations. And essentially, going forward, most water and sewage companies are going to have to find new ways to continue to deliver their essential services for less money. And quite clearly, there is a role that trenchless technology can help with. So thank you for listening. Those are my contact details, and we'll be pleased to take questions. Thank you. Opportunity to speak about flowable backfill at this No Dig conference. My name is Ian Naismith. I'm a senior research fellow at the Institute for Underground Infrastructure, which is based in Germany with offices in the Netherlands and in the UK, which is where I am based. We are an engineering research institute that undertakes work primarily for sewer network owners to evaluate issues that they have and identify solutions. So the talk I'm giving now is divided into 5 parts. I'm going to explain what we expect from flowable backfill material, explain the background to the evaluation that we undertook, how that was undertaken, what the results were, and what conclusions did we come to at the end, particularly with regard to quality assurance. So what is flowable backfill? Well, it is backfill that can be poured into a trench, will spread out, in theory self-level, surround pipes or other structures, and does not require compacting like normal backfill. But it is a mixture of materials. Natural soils or sands and gravels are brought in, or recycled materials can be used. You have binders, you have various add-ins like stabilizers, and its consistency is usually controlled by the amount of water that it contains. But what are its advantages? Well, it can be used in these hard-to-reach areas. So perhaps areas where it's difficult to get other normal compacting equipment into, because we're always interested in being able to properly support pipe work and underground utilities. It's particularly useful in sewer or pipeline construction as a consequence. Because it's flowable, the expectation is that it will self-compact and it will fill the available space without creating any cavities, without the need for mechanical compaction to ensure that. And in theory, it should be homogeneous, constant throughout in terms of its volume and stability. But particularly, what you want from a flowable backfill, which makes it different from flowable cements, foaming concretes, that type of thing, is that you can re-excavate it when you want to, and you should be able to re-excavate it easily, so you can get back down onto those utilities. We mentioned the homogeneous bedding of pipe. Now, one issue with conventional backfill is that it's difficult to get into the haunch areas underneath the pipe in order to properly support it. So with a flowable backfill, this should sort that issue out for itself. And it can be useful if you've got low coverage above, or if you've got other sort of the intricate arrangement that you get underground. It can flow in and around all of the structures that are there. We mentioned the no compaction device being required, so in theory you can have smaller working spaces, narrower trenches. As a consequence of no compaction, less vibration, reduced emissions, perhaps lower excavation costs with the narrower trenches. And it's adjustable. You can adjust the composition depending upon what you want in terms of how quickly you can walk on it, what sort of final strength you require, and the requirement for re-excavation. Because it sort of flows around with very little space or pores in between, it can provide protection against root intrusion and also against infiltration or exfiltration of water into or out of a pipe. And it can have properties in terms of being non-permeable to gas. However, it's a liquid. And so one of the things you have to be aware of is that if your pipes are empty, you may get buoyancy issues. So you have to use some form of buoyancy control. You need to consider the static calculations, because you're introducing this liquid into the trench, the interaction between it and the surrounding soil. And you may require lining of the narrow trench, and you need to be considering the fact that it's flowable, so it could leak into other spaces. So you have to be sure that there's nothing else it's going to go into where it shouldn't. So what it might look like at the end of the day: poured into a narrow trench, filling around the pipe, getting into small tight spaces between different utilities, and working quite well in odd shapes where it might be otherwise very difficult to get in and do your normal compaction. So what did we do with our evaluation? Its objectives, and the objectives of all of these evaluations we do, are to create market transparency, to reduce the investment risk for the sewer pipe owner who is wanting to commission the pipe and use this material. The project we undertook was funded by the Ministry for Environment in North Rhine-Westphalia, which is Germany's largest state, Länder, and also from a group of 13 German sewer network owners, and they formed the steering group for the project. And the steering group made all the decisions, advised by IKT, but they selected the products to be evaluated, the manufacturers to use, the suppliers, development of the test concept, and what kind of evaluation scheme was used. The outputs from this are 2 reports. There is first a report on this comparative exercise we undertook, and then there is going to be, which is already published and in the public domain, and then there is a wider project report which will be published looking at the wider issues surrounding this and the QA lessons that were drawn out from it. And what does it mean for the market? The consequence of this exercise is that the sewer network owners understand quality assurance issues. They can call for improvements on products or look for improvement in products, and they become informed customers or informed clients who know what to ask for. So how do we go about this evaluation? Well, we created in a large test pit that we have at IKT 5 identical pipe trenches. These were 3 meters wide, 3.5 meters deep, and 6 meters long. And in them we placed 2 manholes, a concrete and a plastic manhole. We had a sewer pipe running between them and various other pipes. Also, we were interested in shoring. The next slide explains how this worked, because we wanted to know what happened when we ripped the shoring out of the sides of the simulated trench and to see what happened to the flowable backfill. So what we created was these boxes either side, simulating a narrow trench with shoring that could be removed. We filled them with sand right up to behind the shoring in 2 cases, but we left a void in the others, as you might find in an uneven trench. We wanted to see what would happen when the flowable backfill moved into those voids when we removed them. And another view of the layout from above, just showing the pipe arrangements. We were interested in how it would flow around small arrangements of pipes, so we created a little box of pipes here. We had the main pipe, which is at the bottom, and then we had 2 more sewer pipes higher up. Also, there were some cross members which are supporting taking the weight between the 5 cells. There were 5 identical cells like this. And we needed an evaluation scheme, and this is what the sewer network owners came up with. Now, it's divided into performance checks, maximum score 85%, and quality assurance, which accounted for a further 15% of the overall score. And we divided it into 3 phases. So we looked at how the product performed during installation, during use, and then at the end, disposal. So we dug it up to see what would happen and looked at the material. On the quality assurance side, we looked at various aspects to do with the delivery notes, what monitoring was in place by the installers, what quality issues, quality marks they had, training, and we also looked for anything notable which occurred during the project that we weren't expecting. Now, we had a couple of knockout criteria, or KO, as opposed to OK, the KO criterion. So if it didn't flow properly, that would be a failure outright in the installation phase. If it doesn't become strong enough to be able to build over, i.e. put a road back on it, that would knock it out in the use phase. And we also needed to know whether it could be re-excavated easily and recycled. So that was how the overall scoring system operated. We selected products. Now, there were 16 relevant products available on the German market that were discovered. This is in the last couple of years. The project finished this year. We looked at what we wanted in terms of composition of the material, the requirements set out by the steering group. It was important that it could be delivered within the state of North Rhine-Westphalia to our laboratory in Gelsenkirchen, where we were doing those tests, but we also had field sites where we had it poured into trenches, and we needed it to be delivered there, and it must have to be pumpable, because part of our large test rig is above ground, so it needed to be able to be pumped up over and into it. And we ended up with 5 products being selected that met all of those criteria, and that was felt to be representative, probably, of the 16 products available in Germany. So first of all, we did the installation phase. So we're looking here at flowability, how it could support pipes, what happened when we ripped that shoring out, how stable was it volume-wise, and the accessibility was how soon could you walk over it? And that scored variously scored, contributing 40% to the overall 85% for the performance checks. So with the flowability, the most basic test is done as you might do with other types of flowable concretes, etc. It's spreadability. How wide does it spread when a certain amount is poured from a particular height? And we looked to see how that would function. And there were a range of issues as well to do with it. The consistency of the material, its stability. Self-leveling was interesting. We only put the poured the product in at one corner of the trench, and when it was finished, we looked to see, did it actually level across the whole trench, or was it higher at one side and lower at the other? Now, anything you see in green means that it was fine. Anything in yellow means that there were some issues with it. We scored up the points and we issue a grade. Now we use a grading system from 1 to 6. Grade 1 is excellent, down to grade 6, which is poor, or rather not usable. So you will see this throughout the presentation. We looked at the pipe support. So when we came to the excavation, we excavated down very carefully and we lifted out things like the shoring between, or the bracing. We lifted out the longitudinal pipes, and we also lifted out the main sewer pipe to see what it would look like underneath. And these are the sorts of things we found. These were fine. We did find in some cases that there were small voids, but overall those were statically irrelevant. When we did the static calculations, they were not going to severely impact the support to the pipe. And we got a range of results again, but one product actually we found we couldn't excavate. It had set so hard we had to use mechanical equipment to break it up, and so we were not able to tell how well that had actually performed as we were breaking it out of the ground. But with the others, we had 2 which had absolutely no issues. We had a few small cavities and 1 or 2 others, so we've got scores between 1 and 2 for the other 4 products. When we pulled the shoring out, that was interesting. Now, we don't know when to pull it, so we asked the advice of the suppliers. How long do we leave it before we pull the shoring out? So it was more their decision, and we discovered we've got a range. We look to the right here. We have we've pulled it out, it's refilled, and we've got no cracking. But in 1 or 2 cases, we got a variety. We got cracks forming. This didn't go all the way to the bottom because when we excavated, we discovered it. But certainly up at the top here, a whole range of cracks or voids appearing. The result from pulling the shoring, again, fairly mixed results. 3 of them were very good. A couple of them had issues where that I showed you there, where we had the breaking up of the surface. It could have been that we were advised to pull the shoring too late. So that is something that has to be considered with this type of product. We looked at volume stability. So this is a product containing water. And so in these tubes, we looked to see what happened in terms of settlement and also the settling out of the water above. And we scored them again. And we've got a range of scores from 1 to 2 here. Accessibility was this question of walkover. So we used some weights, and we were looking at the requirement was that it should be at least after 12 hours. We got one product that could be walked over within 3.9 hours. One which took 30 hours, which scored a 6. This one here, 23 hours, scored a 5. Well beyond what we were looking for. So going to the use phase, we looked at the ability to build over. That was one of the failure criteria. So then we used a static load plate to look at what level of support it was able to produce. Now, it's after 28 days. This is a sort of a fixed time, but obviously in many cases it would have been possible to build over earlier than that. We had one product that took 56 days, and after 56 days it still wasn't properly supporting. Others, we had a 7-day value here. And we also looked at risk of subsidence, so we're looking at where does it shrink over time. So we did these initial volume stability, but we also then did some longer term exercises in pots where we were looking to see how it shrunk and whether we had issues of subsidence risk, but that was not an issue in most cases. Looking at the tree roots, when you have tree roots growing in or near a pipe, it's usually because it is following the path of least resistance. So a series of cracks on the surface here would allow tree roots into this structure, but as we discovered, it didn't go all the way through to the bottom. Also here around the sides of a couple of sides of the manholes. We're seeing a bit of shrinkage. And we also got odd little bits of shrinkage or cracks around the edge of shoring, which would be roots to get through. We did do some experiments in pots with ordinary soil and pots containing the liquid fill, and we did in one case have some evidence of roots managing to get through the liquid soil, but in most cases they couldn't. So again, a range of scores were achieved from the different planting trials. When it came to disposal, we did have some issues. The steering group members went in with spades. This is them trying to dig into the surface of one of the soils, which they couldn't do. We ended up having to get the contractor in with digging gear to cut it out, and it was not successful as a consequence. So with re-excavatability, we actually had 2 products which proved very difficult to excavate, and 3, only one which was really excavatable, but the other 2 weren't too bad. With recycling, that again was interesting. We had to look at the recyclability and using a scoring system in Germany, which is based upon acceptance in landfill sites. We did have one product which would not have been acceptable in a landfill because of its chemical composition. Then when we moved on to look at the quality assurance, we found a range of results there, ranging from no issues, which shown in green here, to some minor issues to do with training, etc. But under conspicuous features, one product, they didn't deliver enough material. They had to go back and get some more, so we didn't get what we had originally asked for. There was some issue with the calculation of how much material was delivered to site. One product as well, they ended up adding some water when they got on site in order to make it flow better, and then we discovered that the warranty was invalidated because water had been added on site. And one product, we had an issue when excavating it of the smell of ammonia, which exceeded the acceptable limits, and we ended up having to use gas masks for the staff when they were excavating. So the overall scores that we got from these products, bearing in mind this is the overall score, and it's rated upon 85% for the performance and 15% for the quality assurance. So we had a couple of goods, one unsatisfactory, which was the reason it was marked down was because it was a bit difficult to re-excavate, and we had 2 that turned out to be inadequate. One because it was more or less solid when we tried to re-excavate it, and we had the one which had a number of issues to do with particularly the recycling and disposal. So if you remember, we had these knockout criteria that if you failed them, that meant that it wasn't acceptable in that formulation. So what were our conclusions? We found large differences in quality, as you can see. But we did discover that the various advantages of flowable backfill could be achieved in terms of pipe support, flowability, and re-excavatability. Generally, it was calculated they could be built over after 7 days, and it may obviously be less. You could do more calculations possible. We realized that the knockout criteria that had been identified by our steering group were the ones that people should be looking out for. And it was realized that a lot of the issues that were discovered, the one that wouldn't excavate and the one that had various issues to do with its recyclability, were down to the management or the quality assurance of the mixing plant and the materials that were used. So that is something which is normally out of your control, and you've got to rely on good QA by the supplier. There is a real conflict, if you like, between re-excavatability and being able to walk over or build over quickly. So that is down to the formulation, the mixing, and that needs to be carefully taken into account. We discovered that when you pull the shoring out, you can get disturbance, and that is a bit of an art getting that right and knowing when to remove the shoring. So that's based upon experience. And quite clearly, there is a requirement for quality assurance and supervision on the construction site. We realised as well in Germany there were very few suppliers that could supply across the whole of Germany, so it tends to be more a sort of a local supply is the way in which this market works. And to finish with, I mentioned that there is a report which is publicly available on the website. You can find it again through our IKT website or using this link. There will be a full report out in due course, and there's contact details at the bottom here for emails for myself and Dr. Mark Klamath, who was the project manager for this. So thank you very much for this opportunity to present this, and we now go into questions. For the No-Dig conference. My name is Ian Naismith. I'm a Senior Research Fellow with IKT, the Institute for Underground Infrastructure, which is based in Germany with offices in the Netherlands and the UK, which is where I am based. We are an independent, not-for-profit research institute, and everything we do is undertaken on behalf of sewer network owners to help them address issues that they have and come up with solutions. So why are we presenting today on the subject of manhole rehab? Well, it started really 2 decades ago when German sewer network owners first were becoming aware that there were products available to help them rehab sewers, particularly in relation to issues concerning preventing infiltration. We did a little more work on something else that was of interest to them, which was odor control products that could be put beneath manhole lids in order to stop smells of getting out. But then our main research was undertaken from 2012 to 2016, culminating in a major study comparing the performance of different technologies that were available. And since then, we've been doing quality assurance field studies involving hundreds of manholes in the Netherlands and Germany, and running training on 2 to 5 day training courses. So what I'm going to talk about are 3 things: setting the scene of what happens with sewer manholes in terms of their primary and secondary functions, and then how we went about comparing the performance of rehab techniques, and finishing with some of the lessons that we learned. Well, what about sewer manholes? They are more than just a manhole cover, of course, which is what most people see. Down the shaft, they're actually possibly the poor relation of the sewers themselves. A lot of effort goes into keeping the sewers flowing, not so much effort into managing the condition of the manholes, although the obvious thing is often failure of the rungs which allow access, and you can see in this case they've been removed. Well, primary function is the relief of pressure internally, and of course when this is happening this can cause damage to the interior of a manhole shaft. And another primary function is the accessibility, obviously for people and equipment to get in, so climbing technologies and equipment to stop falls and encourage occupational safety are important, as is concern for atmospheric measures relating to dangerous gases. And another third of the primary functions is ventilation, so allowing oxygen to get in, and unfortunately of course that does result in odour nuisance. There are a number of secondary functions. Of course, as a shaft, as a structure which is part of the sewer network, a manhole should not allow infiltration. And if you get uncontrolled water ingress, this can often result, for example, in the overloading of sewage treatment works, where too much volume of water is being received by them during periods when the groundwater table is high. And conversely, you can get exfiltration of sewage into aquifers as a result of damage to sewers. You've got to remember that apart from the chamber, you've got the seals which connect into the water supply, the pipes going in and out of the manhole. So another secondary function, it has to resist loads from above, from below, and from the sides. From the surrounding soil, etc., in order to correctly function. So any rehab does need to take that into consideration. And a final secondary function is there is a road safety issue, of course, with the manholes on the top. So what did we do about comparing the performance of rehab techniques? Well, the sewer network owners had started to realize that although they had these techniques available, various linings, they weren't always functioning properly. So they wanted to know which ones are suitable, what have they got to look for. And the exercise we undertook, which is an IKT compare or comparative project, was to look at, can you permanently make a manhole watertight by using a rehab technique? And they wanted to know what were the strengths and the weaknesses of the technologies that are available, what quality to expect, what issues to look for. We were required to undertake a one-to-one scale evaluation. And the whole project was funded by the Ministry of the Environment for North Rhine-Westphalia, which is the largest of the German landers, and a group of 17 of the cities which own the sewer networks, who formed the project steering group. Now, we have a procedure that we follow with these comparative projects. We've done them for sewers, lateral connections, lateral sewers, the manholes, flowable backfill, a whole range of products. We always start by working with the sewer network owners to understand exactly what the problem is that needs to be resolved. So we looked at the real situation in the field, and that involved going out with the members of the steering group and looking at their manholes and working out with them what's the actual problem they want to resolve and what are the causes. Something that also became clear was that there are many different types of materials used for manhole shafts. So we've got here concrete and masonry, a range of plastics, stoneware, and some combinations. And what was realized was that in Germany, the majority of manhole shafts are concrete. Then it's masonry and relatively little plastic. That's relatively new, the concept of using a plastic manhole shaft. So it was decided by the steering group the focus would be on concrete shafts. And we then undertook a market survey of standards, but also the available solutions, available technologies. What was out there that was available to them to undertake rehab and that needed to be compared. So we came up here with, essentially they fell into three technologies: mortar coatings applied to the inner surface of the manhole rings, plastic coatings, which could be sprayed on, for example, or applied in various ways, and then linings. These are more physical linings where you are bolting together or inserting something which is creating a new chamber within a chamber. And there were a number of representative products within each one of these technologies. So we were comparing technologies using a selection of representative products. So for the 1-to-1 scale rig, we use the large test pit at IKT. This is 15 meters long, 6 meters wide, and 6 meters deep. And we built a number of manhole chambers or shafts using new materials, but with simulated damage patterns. Once these were built up and the whole pit was filled with sand, it looked like this. And when the suppliers of the rehab techniques came to do their rehabilitation, this is what they saw, and they had a proper manhole to work through. A couple of extra things to point out in this photograph, which are typical of the projects we do. We do undertake a bit of research as well. So there were a couple of rectangular shafts were introduced as well at the request of a Dutch participant in the project, because they wanted to see how the spinning spray heads worked in terms of getting an even spread into a rectangular shape rather than a round manhole. And also, I mentioned before plastic manholes. Well, there was an interest in do these things float? If we fill this with water, because we have the ability to fill this sand-filled chamber up with water to simulate groundwater, did the plastic manhole float as a consequence? Well, having decided upon what the 1-to-1 scale evaluation would be like, we had to come up with a scoring system. And what happens in most of these exercises we do, we score according to performance, but also quality assurance. What sort of QA systems were in place by these suppliers. So in this case, the performance or system tests were given a weighting of 85% and the QA 15%. And looking down with the system tests, water tightness was considered to be the most important, so that scored 40%. The load bearing strength of the product, 20%. The robustness of the system, 20%, and acceptance. Now, this acceptance impression was actually because the steering group members had commissioned the work. They wanted to have a bit of a final say in whether they accepted what had been done. So this was based upon their impression when they saw the completed products. On the QA side, we look at a range of things: the installation manual and procedures. If it's followed, does it mean you can do a proper installation? And the technical data sheets for the products that we've been used. We wanted to know whether the contractor staff had been trained and what sort of training was available to people who use this equipment and materials, and whether there were test certificates available, and what sort of external monitoring or monitoring program did the contractor have in place to ensure that what they installed was done correctly. And finally, we look out for anything conspicuous. So if there's anything that occurs during the evaluation that was not anticipated in advance but is considered to be significant, that gets a mention as well. So the test setup, here's looking in a sort of a cross-section through it. We have a number of chambers that were created, and we have the ability to fill the entire test pit with water. So we can bring it right up to near surface level to simulate rising and falling groundwater. Now, I mentioned that we put in some artificial damage, and in conjunction with the sewer network owners, it was decided that there would be a series of holes. There will be a series of damaged ring joints where the rings that make up the manhole shaft were stacked upon each other. Some more extensive patches of damage with multiple holes. And also, because there was a particular interest, how do these products perform if the substrate behind has not been properly prepared? These are particularly for the ones which rely on adhesion to the wall of the manhole. We put on a mold release agent, which would mean effectively the product wouldn't stick. And these were just done deliberately to see what would happen. It's part of the experimental side of this exercise. So we selected these products, or rather the steering group selected them. And something to bear in mind is that when we do these projects, we invite the suppliers in to see the experimental setup and comment on it. If they say, actually, what you're asking us to do is something our product cannot do, we accept that. And it may be that they decide to continue anyway, but we don't include that in the evaluation because they declared that they can't fix that, but it may be done for experimental purposes. So they get a chance to comment on it, and we take that into account when we are devising the final experiment. But the other thing is they're given a tender document and they are paid. Just like it would be a normal installation, they are paid to come and install into the manhole chambers. And if they decline or they don't want to take part, that was also recorded and included in the project report as the reasons why they didn't want to be part of it. So they came and did their installations, and we observed the installations, what quality control was involved, and it also gives some indication of costs, manpower, and the relative amount of time involved for using different techniques. The evaluation, having done the installation, I mentioned we can bring the groundwater up and down, was that we looked at the initial state, what was the product like, and how does it perform with no groundwater pressure when first installation. We then did a filling exercise in steps from 1 up to the full 5 meters, and looked a short-term exposure to heavy groundwater at a depth of 5 meters to see how they performed at that point. They were then subjected to a 2-month period of that high groundwater and evaluated again. At one point, the contractors were invited in. If there was some small damage which was visible, they were given the opportunity to fix that, so we could see how their repair might perform, the sort of thing that might be required after an acceptance evaluation. And then at the end, the water level was lowered, and we looked at the overall situation with those products. Now, in terms of when we were doing these evaluations, we looked at a whole range of aspects. So we had optical condition, so cracks, holes, color differences, the types of things you could easily see. An acoustic evaluation, tapping, listening for hollows, etc. A haptical evaluation, which was looking really at surface roughness, sanding, scratch resistance of the material. We did look at odor, because essentially if these things smell really badly, and that smell is going to transfer out of the manhole and cause upset for the public, then, or be an issue for, let's say, for health and safety, that had to be considered. And as I was saying, overall, we were looking to see if there was physical leakage visible. We did adhesion tests to see if they would pull out, and we also did some wall stiffness tests using something called the MAC extensiometer. Sort of things we found. So here's the mortar linings, damp patches, cracking, issues around the footsteps. That was a particular thing we were interested in, as to how these products could cope with the ladder arrangement or the step arrangement within a manhole, and actual leaks. And if we look again at the plastic, we had one system that failed. It actually came away from the wall and bowed out under water pressure, so it was impossible to actually get down to the bottom of the manhole. This was essentially unsafe. We got the small leaks, we got bulges, and again we did find some issues around how they could cope with the steps. Again, this is the sort of thing that might require going back to have some further work done at a later date. And I mentioned a number of other tests. We did the pull-out test using devices to check the adhesion to the side for those systems that relied upon bonding to the wall of the sewer pipe. And this extensiometer applies pressure, and we can monitor movement to see what sort of strength is created by the lining system. I mentioned the project steering group had a say. They went down into each one of the manholes, they had a look themselves, and they were able to comment on anything that they felt would be of concern for them if they were accepting this as a completed project. We also, because we like to check what we see in the lab when they do an installation, is that the same as for real? We will go out and look at real installations of the same products. Well, the results are tabulated, and you can there's some links at the end to show you where you can get hold of these. We score the system test, the performance, and the quality assurance, and there's a lot of other information. Too much detail in here for me to explain, other than say that we score from 1 to 6. 1 is good, 6 is bad, and we had a range of good to satisfactory here. And on the second page, we got down to one which is barely sort of sufficient or adequate, and down into not evaluatable. That was the one that failed. So what lessons did we learn from this? So first of all, we did learn that you can get reliable rehabilitation of a manhole shaft against groundwater pressure from these systems. Not all of them, but there are systems out there which will work in that way. We had a range from very good down to adequate. What was very clear was that in most cases where we did see a problem, it was deficiencies in substrate preparation. This was in the field, but also with those simulations we did. So if you don't have good preparation of the substrate and the material can't bond, then you may be it will result in problems. We also found that if there are problems, they will appear immediately. What we tended to find was that when we raised the water table, we would see damages appearing, and they might get worse over time. But what we tended not to see over time was anything new appearing. So that has lessons for inspection. So what we recommend is, on acceptance, a product is inspected when the groundwater level is high. So it might have to wait to a wet season to do a formal inspection. The load-bearing capacity using that MAC system varied quite widely. And we got a whole range of things from relatively deficient to excellent. We found in some cases there was no structural analysis certificate that could be provided for the product, so we didn't really know what the load-bearing safety information was for it. And in fact, quality assurance tended to be very patchy. And the majority of the system suppliers, they weren't able to provide training certificates or testing certificates or approvals. So there were some issues there. And we did do this MAC extensiometer with some sort of crack rings to see what would happen. We got a range of overall stiffness. We found the plastic coatings that the stiffness was a bit lower, but a combination of the plastic with what was left of the surrounding rings did return the original stiffness of the concrete. And the final sort of overall, once again to say, is poor substrate preparation that we believe would be the thing that was most likely to let down a system like this. So that ends the presentation. There's a summary article available in English, and there are full reports available in German online. IKT, we publish all of the work we do in the public domain, so you can find it there. There's a couple of websites, and there are the contact details for myself and Marcus Gillar, who was the project manager. So thank you very much for this opportunity to make the presentation, and I think it is over to questions now. Hello, and thank you for the invitation to make this presentation on the rehabilitation of sewer manholes for the No-Dig conference. My name is Ian Naismith. I'm a Senior Research Fellow with IKT, the Institute for Underground Infrastructure.
Up above the world so high and down on the grounds The advancements that you see in India's aviation is the success saga of the excellence shown by Airports Authority of India. AAI is constructing, operating and maintaining world-class airport. Along with that, AAI has a side that's down to earth and close to the people. One that's clearly visible in its CSR programs and activities. Through its CSR activities, AAI has keenly focused on skill development. To generate livelihood opportunities in backward and remote areas, AAI has tied up with Construction Industry Development Council for skill development of unemployed youth and people belonging to economically weaker sections.
In construction industry, there is a huge shortage of skilled manpower. At the same time, there is a unemployed youth. So if we provide them a skill, it will be a win-win situation for both.
Through this skill development training, the student get theoretical knowledge and practical knowledge in construction-related subjects like land survey, electrical wireman, general work supervisor, site accountant and storekeeper, etc.
Actually, here we are providing trainings to the unskilled youth of India who are unemployed. We distribute pamphlets at the different locations of UP, Bihar, West Bengal to get the unskilled manpower. Then we can make them skilled. So we are providing them 3 months training.
More than 5,000 students have been trained with this skill development training program since 2015.
जब मैं यहाँ पे आया था तो इस सब्जेक्ट से रिलेटेड मेरे पास कुछ ज़्यादा नॉलेज नहीं थी, लेकिन यहाँ आने के बाद इस फील्ड में मुझे काफ़ी नॉलेज मिली है।
हमारे 2 महीने हो गए ट्रेनिंग के और 1 महीना बाकी रहा, हमने काफ़ी कुछ सीख लिया 2 महीने के अंदर।
यहाँ से मतलब सीख के जाएंगे तो हम दुकान खोल सकते हैं अपने घर पे जाके, मतलब हम अपना कोई भी बिजनेस फैला सकते हैं।
ये बहुत अच्छी अपॉर्चुनिटी दे रहा है एयरपोर्ट और CIDC, जिससे कि बच्चे अपना आगे का फ्यूचर बना सकें।
With this skill development training, AAI has generated employment for many of underprivileged and uneducated youth. And on the other side, AAI and other PSUs got a skilled worker for their construction sites.
ट्रेनिंग से हमको मतलब बहुत लाभ हुआ है। मैं आज यहाँ पे जॉब पे हूँ और मेरा काम यहाँ पे जो है प्लांट को चलाने का है। मतलब जो बाहर से ऑर्डर आता है कंक्रीट का, मैं डिस्पैच स्लिप से उसे यहाँ से बना के मतलब माल को बनवा के और वहाँ पे साइट पे भेजना होता है हमको।
पहले मुझे कंप्यूटर की बिल्कुल भी नॉलेज नहीं थी, फिर धीरे धीरे मैं 3 महीने में इतना सीख गई कि वो लोग मेरा कॉन्फिडेंस देख के मुझे यहाँ पे एम्प्लॉय रख लिए।
Our motto by doing all CSR activity in Airports Authority of India is to make the difference and feel the difference.
Airports Authority of India has come to lend a new and distinct prominence to India on global aviation map. And we share this pride with every Indian. And we shall continue to serve them and enrich lives of Indians everywhere.
सेंटर में फूड प्रिजर्वेशन का ट्रेनिंग ले रही हूँ। यहाँ पे हम प्रैक्टिकल कर रही हूँ। यहाँ पे हमें अचार बनाना, जाम बनाना, जेली बनाना आदि सिखाया गया है और उसके साथ यहाँ पे मार्केटिंग और पैकेजिंग की भी सिखाया गया है। हम जॉब कर सकते हैं या जॉब नहीं भी करें तो उसके द्वारा हम अपना बिजनेस शुरू कर सकते हैं। इसीलिए मैं CIDC और AAI को धन्यवाद देना चाहती हूँ। वो हमें ये सिखाया कि हमें अपने पैरों पर खुद खड़ा होना सिखाया। इसलिए थैंक यू।
मैं CIDC में ट्रेनिंग करने के लिए आया हूँ, जो कि मिनेश्वर इंजीनियरिंग कॉलेज में कराया जा रहा है, जो कि कोरल डिस्ट्रिक्ट में है, असम में। मैं जो ट्रेड लिया हुआ हूँ वो है जनरल वर्क सुपरवाइजर का।
ऑटो लेवल एक डिवाइस होता है जिसके जरिए जमीन का और दूसरी चीज़ों का लेवलिंग लिया जाता है। इस डिवाइस के मुख्य पार्ट्स हैं ये ट्राइपॉड स्टैंड में ये ट्राइपॉड स्क्रू होता है जिसके ज़रिए इसका हाइट एडजस्ट किया जाता है और हाइट के साथ साथ इसका लेवल भी एडजस्ट किया जाता है।
I belongs from Risu, Meghalaya. I first 10 class. My father is a farmer. He earns just rupees 200, 300 daily for family. There is not sufficient. I heard about my son training. Started at ICW-NDIS2020 by CIDC. I got admission and learning a lot about house construction. I learned about foundation, cement, sand, etc. By taking this training, I can make my future is better way. Thanks a lot to CIDC.
आफ्टर 10 पास में बेरोजगार था तो मेरा दोस्त रास ने बताया CIDC के बारे में और मैं CIDC सेंटर गुलाघाट ट्रेड प्लम्बर में ज्वाइन किया।
हम लोग गांव में कोई भी काम नहीं मिला, इसलिए हम लोग जो सेंटर से हम लोग को बोला, इसलिए वो लोग दिल्ली से सब लोग आया और ऋषि बेलपारा में अच्छा काम करना मिलेगा बोला, इसलिए हम लोग ट्रेनिंग के लिए CIDC के आया और हम लोग ये CIDC ट्रेनिंग खत्म होने के बाद हम अच्छा काम चुनेगा।
यहाँ मैं सिगोली CIDC सेंटर में फूड प्रिजर्वेशन में ट्रेड पे हम लोगों को आम के आसार, जाम, स्क्वायर बनाना सिखा रहे हैं। तो यहाँ पे हम लोग यह बेलची स्क्वायर बना रही हूँ। तो ये सीखने के बाद हम लोग पैकेजिंग और मार्केटिंग भी सीखेंगे और सीख भी रही हूँ। और ये इसके लिए हमें तो फ्री में CIDC और AI हमें तो फ्री में ट्रेनिंग दे रही है। इसके लिए हम CIDC को और AAI को थैंक यू बोलना चाहते हूँ जो हम लोग को फ्री में ट्रेनिंग दे रहे हैं। और मैं खुद ये सीखने के बाद मैं खुद के बिजनेस शुरू करूँगी, अगर मुझसे हो सके तो मैं जॉब भी करना चाहूँगी।
My father is a teacher. I'm taking training in Muslim Trade at Nongstoin Center. I have learned about the construction material, measurement, the foundation, brick, masonry, extra from Pawan, from South Pawan. After training, I can work this trade and earn my living.
हम लोग अभी पहले तो हम लोग 200 रुपया ऐसा मांगेगा। अभी हम लोग CIDC से ट्रेनिंग लेने के बाद हम लोग जो काम उसको हम लोग सीखेगा, उसको हम लोग अभी 500, 600, 700 ऐसा मांगेगा।
मैं असम से आई हूँ, मेरा डिस्ट्रिक्ट गोलाघाट। मैं पहले से गोलाघाट इंजीनियरिंग कॉलेज में CIDC पार्ट की सब्जेक्ट फूड प्रिजर्वेशन के लिए 3 मंथ की कोचिंग करने के लिए आई थी। वहाँ मैंने फूड प्रिजर्वेशन क्या है वो सीखा है। तो वहाँ पर मैंने सिडोली सेंटर में ट्रांसफ़र की गई है। यहाँ पहला दिन से मैं आसार, जैम्स, जेली कैसे बनाती है वो सब सीखा है। और उसके बाद मैंने मार्केटिंग और पैकेजिंग भी बहुत सारी बातें सीखने के मिले हैं। तो इसीलिए मैं जो भी जॉब और ना तो मैं अपनी बिजनेस शुरू करना चाहती हूँ।
Up above the world so high and down on the grounds, the advancements that you see in India's aviation is the success saga of the excellence shown by Airports Authority of India. AAI is constructing, operating and maintaining world-class airport. Along with that, AAI has a side that's down to earth and close to the people. One that's clearly visible in its CSR programs and activities. Through its CSR activities, AAI has keenly focused on skill development. To generate livelihood opportunities in backward and remote areas, AAI has tied up with Construction Industry Development Council for skill development of unemployed youth and people belonging to economically weaker sections.
In construction industry, there is a huge shortage of skilled manpower. At the same time, there is a unemployed youth. So if we provide them a skill, it will be a win-win situation for both.
Through this skill development training, the student get theoretical knowledge and practical knowledge in construction-related subjects like land survey, electrical wireman, general work supervisor, site accountant and storekeeper, etc.
Actually here we are providing trainings to the unskilled youth of India who are unemployed. We distribute pamphlets at the different locations of UP, Bihar, West Bengal to get the unskilled manpower. Then we can make them skilled. So we are providing them 3 months training.
More than 5,000 students have been trained with this skill development training program since 2015.
जब मैं यहाँ पे आया था तो इस सब्जेक्ट से रिलेटेड मेरे पास कुछ ज़्यादा नॉलेज नहीं थी, लेकिन यहाँ आने के बाद इस फील्ड में मुझे काफ़ी नॉलेज मिली है।
हमारे 2 महीने हो गए ट्रेनिंग के और 1 महीना बाकी रहा, हमने काफ़ी कुछ सीख लिया 2 महीने के अंदर।
यहाँ से मतलब सीख के जाएंगे तो हम दुकान खोल सकते हैं अपने घर पे जाके, मतलब हम अपना कोई भी बिजनेस फैला सकते हैं।
ये बहुत अच्छी अपॉर्चुनिटी दे रहा है एयरपोर्ट और CIDC, जिससे कि बच्चे अपना आगे का फ्यूचर बना सकें।
With this skill development training, AAI has generated employment for many of underprivileged and uneducated youth. And on the other side, AAI and other PSUs got a skilled worker for their construction sites.
ट्रेनिंग से हमको मतलब बहुत लाभ हुआ है। मैं आज यहाँ पे जॉब पे हूँ और मेरा काम यहाँ पे जो है प्लांट को चलाने का है। मतलब जो बाहर से ऑर्डर आता है कंक्रीट का, मैं डिस्पैच स्लिप से उसे यहाँ से बना के मतलब माल को बनवा के और वहाँ पे साइट पे भेजना होता है हमको।
पहले मुझे कंप्यूटर की बिल्कुल भी नॉलेज नहीं थी, फिर धीरे धीरे मैं 3 महीने में इतना सीख गई कि वो लोग मेरा कॉन्फिडेंस देख के मुझे यहाँ पे एम्प्लॉय रख लिए।
Our motto by doing all CSR activity in Airports Authority of India is to make the difference and feel the difference.
Airports Authority of India has come to lend a new and distinct prominence to India on global aviation map. And we share this pride with every Indian. And we shall continue to serve them and enrich lives of Indians everywhere.
सेंटर में फूड प्रिजर्वेशन का ट्रेनिंग ले रही हूँ। यहाँ पे हम प्रैक्टिकल कर रही हूँ। यहाँ पे हमें अचार बनाना, जाम बनाना, जेली बनाना आदि सिखाया गया है और उसके साथ यहाँ पे मार्केटिंग और पैकेजिंग की भी सिखाया गया है। हम जॉब कर सकते हैं या जॉब नहीं भी करें तो उसके द्वारा हम अपना बिजनेस शुरू कर सकते हैं। इसीलिए मैं CIDC और AAI को धन्यवाद देना चाहती हूँ। वो हमें ये सिखाया कि हमें अपने पैरों पर खुद खड़ा होना सिखाया। इसलिए थैंक यू।
मैं CIDC में ट्रेनिंग करने के लिए आया हूँ, जो कि मिनेश्वर ब्रह्मो इंजीनियरिंग कॉलेज में कराया जा रहा है, जो कि कोरल डिस्ट्रिक्ट में है, असम में। मैं जो ट्रेड लिया हुआ हूँ वो है जनरल वर्क सुपरवाइजर का।
ऑटो लेवल एक डिवाइस होता है जिसके जरिए जमीन का और दूसरी चीज़ों का लेवलिंग लिया जाता है। इस डिवाइस के मुख्य पार्ट्स हैं ये ट्राइपॉड स्टैंड में ये ट्राइपॉड स्क्रू होता है जिसके ज़रिए इसका हाइट एडजस्ट किया जाता है और हाइट के साथ साथ इसका लेवल भी एडजस्ट किया जाता है।
I belongs from Risu, Meghalaya. I first 10 class. My father is a farmer. He earns just rupees 300 daily for family. There is not sufficient. I heard about my son training. Started at Risu Welfare by CIDC. I got admission and learning a lot about house construction. I learned about foundation, cement, sand, etc. By taking this training, I can make my future is better way. Thanks a lot to CIDC.
आफ्टर 10 पास में बेरोजगार था तो मेरा दोस्त राज ने बताया CIDC के बारे में और मैं CIDC सेंटर गोलाघाट ट्रेड प्लम्बर में ज्वाइन किया।
हम लोग गांव में कोई भी काम नहीं मिला, इसलिए हम लोग जो सेंटर से हम लोग को बोला, इसलिए वो लोग दिल्ली से सब लोग आया और CIDC वेलफेयर में अच्छा काम करना मिलेगा बोला, इसलिए हम लोग ट्रेनिंग के लिए CIDC के आया और